Yo, what's going on, man? I just received my contract laptop for work. It sucks. It looks so bad. Not excited. Oh shit, I need to mute myself. How you doing? It's alright, it's alright. It's fuck, dude. Oh, it's so annoying. I was hoping I could start my contract role Monday, but they want me to start tomorrow. It's not ideal because I have shit going on this week. We'll see, we'll see. But yeah, it's a contract role. Um, but I have stuff going on, so I don't really know how to navigate this. Uh, yeah, I'm still trying to figure out how to approach this. But yeah, I don't know. We'll see. The laptop they gave me is really bad. Um, I don't even know if I can use my own laptop because I'd rather just use my own laptop if I'm being honest. I think the laptop they gave me is like this super old Windows. I think it's like a ThinkPad. Yeah, dude, it's literally this old shit with the little red. Yeah, man, it's terrible. It's literally this. They gave me this laptop to work with. So bad, so bad. Yo, what's going on, Dumai? Doing fine. You just touched down on your internship. You've been unpacking all day. Oh, nice, dude. How you enjoying the location change? Yeah, dude, it's a fucking ThinkPad, man. Yeah, and I'm supposed to use that for work. So I can't connect like all my monitors and even if I do, I think it's gonna like probably throttle the computer because it won't be able to handle the load. Um yeah, and it's super slow, so like as far as the amount of work I can actually get done, not a lot at all whatsoever. Yo, what's going on, Adon? Yeah, good evening. I think it's evening for you, right? I'm still doing some interview preparation, so nothing really crazy right now, if I'm being honest. Why? sure that's working. Location been alright. They put you in this really tiny apartment. Oh, so you're actually in the house now? Damn, that's sick. A tiny apartment versus an actual house. That's a 9-day difference for sure. I love it. There we go. So this is good. Yo, what's going on, Survival? Haven't seen you in a minute. How you doing, dude? Dude, I haven't, you know what's funny is I don't think I've ever had a roommate before. That's crazy. Because I went to like a local university and a local community college. I guess, yeah, I've never had a roommate before. But I imagine if people don't align on like, how clean things should be or whatnot, it probably would cause a little bit of drama. Just here to check in. Yeah, I'm doing good. Thanks for checking in, man. How you doing yourself? Developed a lot of self-confidence after cutting off a few people. Nice, man. Congrats. You never got along with this person. Oh, but you get along with this person. You were sleeping here the first time. You came by for a visa. Oh, okay, okay. Nice, dude. Hell yeah. Am I full stack? No, but I'm hoping I will be soon. I mean, I do back end stuff on the front end side of things, but I don't actually do like database languages and stuff. Why don't I use why don't no, I do use Tailwind, dude. You should check my project in the description below. I love Tailwind. Tailwind's pretty awesome. Yo, what's going on, Vinay? Welcome back, welcome back. Hello, Omar. How you doing? Welcome, welcome. Oh shit, I didn't even time myself. It's okay, let's see how far I can go by one. What? Oh shit. Why is it showing my it's not updating. Sorry. Let me fix this really quick. Really weird why it's showing my old screen and not this one. There we go. All right, my bad. Fixed it. So I just created the custom hook. These are constants. So you guys probably saw it yesterday already. This is the main application. I'm destructuring data and returning it as a user, but it looks like I'm getting an error. I'm wondering the errors from here. So oh, does it not let me destructure? Yeah, that's the problem. Cannot read data. Fuck, dude. I want to destructure this to something else. I guess the only way is constants. All right. Stick with this. Why is it not logging? How's my job situation so far? Um, it's in progress. I think right now I am. I have the contract role lined up already, so they sent me the work laptop, but it's a piece of shit. And I would rather use the current laptop I'm using right now, but obviously there are some restrictions because the approved laptop the contractor sent me is I think I don't know if I can onboard with this laptop. But anyways, I'm trying to figure it out. Yeah. Right, right. Yeah, yeah, definitely, man. I'd be down, bro. Just gotta give me a while to kind of like figure things out. Um, so this works, but the name is not showing up. Data.name.first, data.name.last. Why is that not working? Oh, it's user. This is name, that's why. There we go. All right, so it's working now. So this navigation will contain as well as this one. We're passing in the name as well as the image. This one, we're just passing in links. This one, we can simply return image. This will be just do this for now. This would be name. Should be image actually. Nav links. Links. And then this will just be another div. And we'll do a this will be for each link index. We can return a div. Close and nav. And this will return. Actually, this is the button. Return the link with key index. Oops, that. We need to call return. Oops. Why is it not formatting? There we go. There we go. All right, so it's good here. You know it's bad when you rather use your own equipment instead of the free stuff they give you. Oh yeah, that's like, yeah, no contest, dude. That's 100% the fact. Oh man. Like, I use all my monitors. I know it's like kind of like overkill, but I use this as my main, and I definitely still use this. If I have a small ass laptop and I'm doing this the whole time, bro, that's gonna piss me off. Like, I mean, no one said it was gonna be perfect, right? Like, beggars can't be choosers. Clearly, I need the money. If I have to work on a piece of shit laptop like this, I'll figure out a way to make it work. I might have to go to Best Buy and get like a dongle that connects to the USB on this, and that way I can replace these two connectors into the and then connect my monitors into that one dongle, but I just don't know if it'll work. Anyways, so that's that. These are all the nav stuff. That's the app. So now we do I guess we can do body background. What's going on, Param? You're also a coder. Nice. So is most of the people here. But welcome. You want to go to Miami? Cool. Hope you enjoy the crocodiles. That'll be fun for you for sure. Display flex. Miami seems so fancy until you remember it's Florida. True. I'm excited for GTA 6 though. GTA 6 taking place in Miami. I can do all the hooligan shit I ever wanted to do in Miami through GTA 6. And like drive a sick ass modified car and everything. Hell yeah. Mm, like 80% or something. That's still too much. Yeah, super excited for GTA 6, man. For sure. Whoops. Oh shit. Okay. Do I know Mark Manson? Who is he? Wish me the best in job process. Thank you, man. Are these coding streams temporary or are you still gonna do them later on? I might do like a mixture of like gaming and coding. We'll see. Uh, okay, give me 1 second, and then I'll check it out real quick. Actually, that's exactly center. Hmm. Shit, I don't want that. shit. I don't remember how to do this. Hold on. Sounds good, Survival Man. I appreciate you coming back and hanging for a bit, dude. Catch you in the next one. I need to download this. Maybe just do serif. Fuck it, fuck it. Yo, what's going on, Sing? Doing alright, doing alright. How about yourself? Probably just keep these as fragments. Hmm. Actually, do that. All right, we're looking up who Mark. Self-help author and blogger. Subtle art of not giving a fuck. Oh, I do know him. What the hell? Everything is fucked. Isn't he doing super well now? This guy's like, yeah, I totally know about him. I haven't read it yet, but yeah, I heard that. I remember about him publishing that book. It was actually pretty big news when it came out. Hmm. What do I wish I knew in my early 20s? Harsh truths. Good question. Uh, so this is more specific to me, obviously, since this was kind of how I grew up. Um, all right, hold on. This is gonna take some. You asked me a pretty loaded question, so I'm trying to think about a good way. Couple things that I learned when I was in my 20s. I mean, the most obvious one, like don't fucking do drugs. Let's see. What are some other really obvious ones? Don't do things to impress people, I think. That's something that I think even as you get older, it's still something that sometimes you might still care about, but the goal is not to do things to impress people. Really just like you should be working to impress yourself. I think that's one thing that I learned. Because I think I spent a lot of my 20s trying to kind of cater to other people, especially since I was raised around the concept of like being super respectful, right? Like to a certain extent, you need to be really respectful to people, but not at the cost of not being able to be like independent on your own, if that makes sense. I think a good example of this is so I used to hang around like I was never like, oh, what's going on, Zizu? So I used to hang around like like gangbangers and shit like that. So it commands a lot of respect, right? Like so you the way you talk to them, and let's say for example you have like an older brother, right? Your older brother, you need to always be respectful and always give them even if they're wrong, you need to just agree with them. And I think that's something that is just not correct. I think a better way of handling situations like that is just to um, you can believe that they're wrong. You don't necessarily have to say that they're wrong, right? But just keep it in your mind and know for a fact um, that you can disagree with them, and if you know that they're gonna be like very hard-headed, you don't need to voice your opinion because it's like arguing against like a brick wall, right? Um, so that's probably one thing that I think I learned. But also like in general, staying away from the wrong group of people is pretty important. The people you hang out with tend to foster your sense of how you should behave, which is no good. What's going on, Zebra? Is this like the fucking Bella? What the fuck? Oh my god, bro. Well, you already know what's gonna happen here. Jesus Christ, dude. So, yeah, I don't know what's with these two people, bro. Um, yeah, I can remove them all day. So, yeah, anyways, I used to just hang around the bad crowd. I think the goal was just to kind of just want to like be this is like useless information, I feel like. Because I used to party a lot, right? So that's kind of the environment I was in. I think if I focused more on myself in my 20s, I would be much further ahead in my career and much more stable financially. So I feel like as far as something that's relatable, that's probably what I would focus on. I didn't focus enough in my 20s and I kind of like fucked around too much. So Jesus Christ, dude. The fuck are these people? Okay, anyways, so yeah, I these are the two same people that were fucking annoying as fuck yesterday in the chat. Focusing on myself. Yeah, like basically focus on what you want to do and what you believe will push you further in life. Challenge yourself, right? I think that's something that I was avoiding for a while. I didn't really challenge myself. I lived too much in the present and I didn't live for my future. So, and also what I mean by focusing on yourself too is I don't know like if you have friends that you hang out with that may command a certain amount of your attention. You need to balance like having fun and hanging out, which you should do, and also a certain amount of like preparation for your future. So um I wasted, you know, between the ages of 17, oh shit, I mean it goes back to high school, dude. I fucking wasted my high school time too. Because my grades were terrible in high school. I think I graduated like a 2.8 or something. So between the ages of 16 to my mid 20s, right, like 25, I spent all that time just enjoying the moment of my life, like doing hooligan shit, fucking around, going to parties, drinking, and not focusing on my future. So, but it's a balancing act, dude. Like if you got friends and family, man, you need to focus on your future, but also dedicate some time to your friends and family. Because at the end of the day, let's say, for example, you know, everyone has a plan, right? So you have a plan of like, going to college, getting your degree, getting a job. Along that along that road, some things may not pan out. And if you completely disregard your family or you disregard your friends, um, which I fucked up when I was going to college. I completely disregarded some of my friends, and that led to I basically lost a lot of friends because I was trying to focus on school too much. And so you need to balance between school and friends and family. Um, and it's tough too because sometimes your friends won't understand. And the people that leave your life because you're grinding and you're trying to move up in life, that's gonna happen. It might happen. I don't know what the culture is, in your part of the world, but yeah, some of my friends did not like the fact that I was grinding. They saw my behavior change. Um, Something to get comfortable with is also just like losing friends. It happens, man. Like I don't know if you have like childhood friends or anything, but yeah, losing friends is kind of a part of life. You have to kind of be okay with being alone. So that's kind of like a self-confidence thing. If you're fine with just being by yourself and doing your own thing, I think you'll be fine too. So this is not really helpful information, dude. Why do I feel like this is helpful information? I'm just like so generic shit, dude. Um, I guess also don't be afraid of, like as you grow, your personality is gonna change. That's totally fine. But at the same time, like stay true to yourself. I think a lot of people they grow and they change their personality too much because they're trying to be someone they're not, right? Like they're no longer authentic. Yeah. Dude, yeah, it's the same two people from last time. Like, what the fuck, dude? Fucking saying like ni hao and shit. Like, bro, I know you're not saying that because you actually, you know, fuck anyways. But anyway, so, I think just yeah, be authentic, focus on your future, but enjoy the present. And for me anyway, family comes first. So it depends on, your relationship with your family and stuff. I don't know if that's helpful, dude. Really have no idea. That's probably it. From my point of view, it doesn't seem very helpful at all. But yeah. All right. This is pretty much what they would require. Yeah. I hate it when people like, dude, people ask me for like tips of my life, and like sometimes I just don't know how to respond to that. It's like Vinay earlier asked me, harsh truths of my life. It's like it's so like unique to each person, So like I went through a bunch of shit, but it's like I don't regret what I went through, but it's not really, I don't know if it's like transferable. So yeah, I apologize if that wasn't what you were looking for. Is there anything specific though? Like damn dude, a lot of shit went happened in my life that just shit went down. So it's hard for me to like pinpoint exactly what harsh truths. Family, friends, career, or finances and stuff. Hey, what's going on, Astrox? How you doing, bro? You were gonna say something, but that would be generalizing a certain group. You changed your ways. You're no longer racist. I think okay, the only time racism is even tolerated is if like say for example like I'm watching a comedian, right? Like a stand-up comedy show and there's a comedian who throws around a racist joke, but it's actually funny. That's the only time where I'm like, all right, like this guy gets a pass. But when someone comes in and just goes ni hao ching chong ling long, like dude, what the fuck, bro? Like you think that's fucking funny? Like nah, bro. And then first of all, like it's just this stupid kid on a keyboard thinking that they can say whatever the fuck they want. But when it comes to real life and someone says that shit to me, bro, I'll drop them in like a second. Someone who uses Python, do you think you should learn C++ plus plus or Java? You're using Python right now, but what's your goal? Like, are you planning on doing like is Python just like a gateway to learning more complex languages, or are you just learning Python because you want to be like a data scientist or something? Yeah, data analyst or whatever the case may be. Dude, my face feels so like greasy. I'm gonna go so hold that thought. Basically, you can ask me when I come back, but the general rule of thumb that I give to everyone who asks me about languages and what they should focus on, pick a language in the field that you want to get into, and then kind of like hit the ground running. If you want to do web development, it's probably easier for you to start in the front end because you can see visually like what you're building, and then work your way to the back end, right? If you prefer visualizing the data and moving data around tables, then you might just start in the back end, in which case I would say start with Java and then learn like a database language like SQL or NoSQL for non-relational databases. But in any other case, if you want to be a data analyst, Python's a fantastic language to learn. It's what they use for I think majority of them, and then or majority of the positions available. If you're going to learn something like mobile development, oh, you just want to understand computers and how it works. So you're probably very early in your like future career and stuff. In that case, like I said, figure out what you want to do. If you want to learn about computers and you want to build like an operating system, you want to understand how like computer cores work and memory allocation, all that stuff. C++ plus plus is probably where I would start. But yeah, if it's like web development, dude, you got to start with like HTML, CSS, JavaScript, and then go from there. It's all about context. You were going crazy with the black plus Asian jokes, but it wasn't the first thing I said. So yeah, I mean, yeah, if you crack a joke on yourself and it's racist to yourself, that's fine too. Obviously, right? Like you have every right. But yeah, stupid jokes that aren't funny, that take zero creativity, and are obviously not there for an actual joke, but actually to like offend someone, that's fucking just rude in my opinion. But yeah, I'll be right back. Oh shit, I need some water. Yo, thank you, thank you. Yeah, but all right. So I did some light front end coding. I think I need to touch base on bits and bytes again. They said a terabyte is rare. Yo, so this is a Stanford link on bits and bytes and kind of like just generally how they work. A terabyte is about 1 trillion bytes, and they put it in quotes rare. It's now extremely, extremely common. Have I heard of Mind's Eye? I haven't. What is that? Let me Google it real quick. Let's see what's going on here. Oh, I this morning when I woke up, I watched Charlie do a let's play on it, and it was fucking hilarious. That one fat lady coming out with the shotgun saying like something about like I'm gonna get you, I'm gonna kill you, and then she just gets mowed down, dude. And then the little ATV that he was driving, like the wheels don't spin, they like lag and then they just stay in place. It was fucking funny. Like, Mind's Eye. Let me see what the reviews are on Metacritic. Wow, 46. Ambitious entry from IO Interactive. Bug filled, unoptimized, less. And then he. Dude, you actually got the game? No way. You bought it for shits and giggles, huh? On a side note, I have been playing a game off stream and it's been what's it called? Tainted Grail. Yeah, it crashed on a cutscene, dude. That got me like, dude, I was floored when I saw that shit happening. That was funny. But yeah, so what do you call it? Basically, I've been playing Tainted Grail, and it's been pretty fucking sick. I'm surprised with how much content they have in just the first two acts. And dude, it fits my vibe, dude. I'm all about like the dark shit, you know. I love horror movies and stuff like that. So my character is like just it's basically going around crashing out. I have a two-handed sword build. I'm just fucking bonking people like left and right, dude. It's fucking hilarious. Like in a good way, in a good way. But yeah, if you guys haven't played Tainted Grail, it's on Steam and fucking love that game. It's so good. It seems so funny, but it's so bad, definitely not worth it. But you have no regrets. That's funny. All right. Wait. Let's delete all of that. So again, functional requirements, user management, meetings, updates. Should I do a different system design to practice so I can get a better idea of maybe yeah, let's do that. So computer engineering blogs. Pretty cool. Direction provider. It's pretty neat, actually. I didn't know they developed React dates. What's my monitor size? This one is I think 32 inches, and then this one is 34 inches, and then the MacBook is 14 inches. Oh, they actually included a system design for this. Netflix player, request ads, Edge, Play API, ads manager, request ads. What is Kafka? Distributed data store. Distributed event streaming platform. Is Kafka considered load balancer? It isn't a traditional load balancer. It does spread out messages, message load between partitions while preserving message order. Watching from Bangladesh. Oh, cool, cool, dude. Hey, man. Welcome, welcome. How you doing? Fan out. And then you go to Redis, timeline service, ingester, Hadoop. Hmm. Ingester. Let's add ingester system design. Okay, let's do system design on how to approach system design interview. Yeah, that's pretty much. Start with functional. Start with the functional requirements, non-functional requirements. Let me blow this up really quick. Third year CS undergraduate student. Do I use React or other frameworks? I am basically a React developer. But frameworks, as far as I'm concerned, that I want to get into, um, so Next.js is a really popular one, but it builds on top of React, so it's more of like a library, I would say, not necessarily like a framework. And then I also do want to get into using, so popular libraries that I want to use is like Relay, which is supposed to replace Redux as the single source of truth. Next.js for, server-side rendering. Um, I do want to learn Angular because it's like the second most popular front-end framework after React. Um, and I think Vue is another popular one, but yeah, I think in terms of order of things that I want to try, it's Angular first, then Vue. Do web devs need DSA? Yes. To a certain degree, yes. Um, even if you're a backend, you definitely need to know a little bit of DSA. It's not going to be something that you'll use all the time at work, but I mean they'll use it for interviews, so it's not something that you want to disregard, right? We have assumptions. Popular products by category. Just the service that calculates past week's most popular products by category. Past popular products must be fast. Yes. Items. Items can't change categories. Items. So it's supposed to be updated hourly. Results. For products. for products, we have the ID, which given 10 million products, 10 million products, I think an int should suffice. It's about 4 bytes. So we are tracking analytics of each. It will have the which can potentially just be, I think an int is fine here as well. So 4 bytes. We also have the name, which I believe can just be 7 bytes. So it'll be a combination of alphanumeric, including uppercase. Category. I think for this one, as far as 2.5. It's only 1,000 categories. So each category is 2 bytes. Category ID, 2 bytes. More specific, right? Product ID, category ID, some other IDs I'm looking for. Created product links to seller, so seller ID, 4 bytes. We need, why is product ID 8 bytes? These are all big. What's going on, Waleed? You also in your 3rd year, dude? Almost about to graduate. Nice, nice. Hell yeah, dude. Welcome. Why do you need quantity, dude? Size per transaction. Oh, these are transactions, dude. Transaction. Why does quantity need to be 4 bytes? Transactions, quantity holds. Quantity is the metric, right? Because, okay, that makes more sense. You are a niche and they say they don't know your son. I don't even know what that means. Why is it 5 bytes? 1 billion transactions per month. So hey, what's going on, Akash? Welcome back, dude. How you doing? 1 billion transactions per month. 1 billion transactions per month. There's a billion transactions, roughly 40 bytes. 400 requests per second. $40 billion bytes. And what was the conversion again? Bit to byte to mega to kilo to giga to tera. So when we have bytes, So given the amount of bytes we have, if there's a billion transaction, we have 40 bytes. One billion, so that's 24 gigabytes. 8 bits is 1 byte. 40 bytes. So kilo is 1,000, so kilo is 1,000 bytes. A billion bytes is giga. So giga is billion, mega is million, tera is trillion. So 40 bytes through 1 billion transactions would be 40 gigabytes, right? 40 gigs. So this would be is 40 gigabytes. How long have I been coding? Like roughly 3 years professionally. 40 gigabytes per month. I need to remember this, man. Trillion. How to learn coding faster? Just practice, man. Just gotta practice a lot. Um, what's the plan for today? It's probably more system design. Yeah, it's like probably not super um, fun to watch, but yeah, I'm brushing up on basically how much data exists in each level of unit. So, because I kind of forgot all this, dude. Um, it's been a while since I had to reference this stuff. And so 1,000 bytes is 1 kilobyte, 1,000 kilobytes is 1 megabyte. So So we go to see 1 billion. So 40 bytes to 1 billion. How many bytes are in? So if this is 40, yeah, 1, 2, 3, 6. It goes bytes. Mega is million, so this is 40 million, 40 billion. That puts us in the gigabyte territory. Divide by 1,000. So that's 40 million terabytes. Is this correct? And then divide by another 1,000 gives us, yeah, so giga, tera, petabytes, 40,000 petabytes. Billion transactions per month. This does not look right. 40,000 million billion. So that would be 40 bytes, 40 megabytes, 40 gigabytes, and then 40 terabytes. So total transactions per month is 40 terabytes. And then this is, oops, total reads per month is 400 billion reads per month. So that's 400 terabytes. Is that right? Is that right? 40 gigabytes of new transaction content per month. Reads don't cost space. We're only tracking those. 40 gigabytes. This is 40 million, 40 billion. So 40 bytes. Let's see, wait. So this would put us at 40 bytes multiplied by 1,000 gives us 40. Oh, I skipped kilobytes. So this would be kilobytes, megabyte, gigabyte. Sorry, so there's 40 gigabytes of transactions per month we need to store. And over the course of a year, we multiply that by 12. Or it would be 1 total transactions over 3 years is 1.44 terabytes. This 1.44 terabytes. Okay. This is the client. So we'll go ahead and sketch out the let me delete that. Add this. So this is my client, and the client then needs to obviously I guess purchase the actual item, right? So it will send a request to our web server. Okay, anyways, so it sends it over to our web server. This is our web server. Right, sends a connection down to the web server. Web server then we'll have two gateways. I can just create purple. Read API. Read API. And two of these. And this will be API gateway. So we'll start with the read. I guess we can do both for now. Read and write. So let's say the user reads upon a read API. Well, let's actually start with transaction, right? Let's say they buy something. If it's a buy something, then we will need a transaction service. So this is where we include This is the transaction service. That. So let's connect that to here. For the transaction service, suppose there's probably a couple layers to this, right? So if we are making a transaction, we're making a transaction and the user purchases something. First things first is we need to, there's like a payment processing thing, right? Think here. So with the transaction service, our client makes a request to our web server. Our web server, based on the type of request, will either divert them to the read API or write API from the API gateway. Let's say that the user decides to make a transaction. The product first needs to, we need to when they click buy product, product needs to go to the payment processing state, right? So there is essentially like this is the payment service, which includes, you know, the I guess payment service. What else am I missing here? Payment service, and then I guess we need to record the transaction, right? And then record service. So after that is complete, we will store the transaction in our database. So I guess this would be transaction DB, like that. So payment service, and then payment service goes down to record service, which then gets placed in our transaction DB. We do need another service to rank transaction service, record service, transaction DB. So we do on the read side of things, we have a this is called the ranking service. So we'll go ahead and pull this over to the ranking service. Inside the ranking service, we need to there's a ranking service here. What does the ranking service do? We will have to order by transactions service. So we have that. And then what else are we missing? It's part of the read though. No. Order by transactions. I think the database actually will handle the ordering. Yeah, I think database should handle ordering, but will that be too computationally expensive? We can order by, let's see, we're calculating only by the last week's most popular product category. So database will maintain the order by date. And so for each transaction added, we'll just push it to either the bottom of the table or the top of the table based off the date, right? So in that case, if the database is already ordered, we simply need to pull all of the last week's transition or transactions from the database. So we would have this would be called gather prior week transactions service. And we probably also have maybe a order order by popularity service. And we also want to have a cache here. So for this one, call this cache. Let me delete that, save this. So we have cache and service. This is called ranking service. Okay, so for this cache, let's see, ranking service first starts at gather prior week's transactions and then order by popularity, then stores it in cache. Right. Okay, order by popularity, and then we store in cache. But this actually this pulls data from here. So it actually looks kind of like this. So our cache actually needs to be in between the database and okay, hold on. So this is just a high level overview. We're gonna go ahead and pull from database. Once that data comes back from the database, so I'll make this dotted because we're gonna pull from database. Once the database comes back, we are going to then reorder them as needed and then store them in the cache. And then this cache will actually funnel its way. It will funnel its way back to the API gateway. And then from the API, or actually we can just directly push that back to the web server. And then this will be dotted. And then from there, this will go back to the client. So this is really rough, high-level overview of my design. Whether or not this is accurate, I don't know. Right, so client makes connection with web server, goes through the API gateway. If they're making a transaction, we go through transaction service, which goes through payment service. Then we record the after payment, we can store the transaction, right? This is the record service where we record the if it went through. I mean, I guess even in high level overview, we might not even need record service. We can probably, after payment is secured, we actually just send that straight through. But then what's the point, right? We have payment service, which handles the quantity, the cost, buyer ID, all that good stuff, and then throws into the DB. As far as ranking service, we have two things going on. One, we have to gather the prior week transactions, which it makes a call here. Then data comes back. Sorry, so this will be solid, and then this data coming back will be that. Once we have that, we'll push it over to the ordering service, and then store it in cache, in which case it goes straight back to the web server, back to the client. Oh my god, sales rank service. So they have a read API and a sales API. Well, I just called it right, but I guess we can call it sales API to be more specific. So if this was called sales API, we go straight into two databases. One is object store and one is SQL to store transaction DB, and then one is just an object store. Object. So two things happen here. We have SQL database to maintain transactions, and we have an object store. So sales API, we have ranking service. Weird. So when you call for read, sales rank doesn't happen from the read aspect of things. So read actually goes directly here. Client, web server, read, goes straight to SQL database, channels all our transactions. Okay. Also here we have sales API, which does go, we don't need this. This is getting too crazy. So sales API just goes straight to transaction DB. And it also has another one going straight to the object store. So that's then we have an independent ranking service, which will, so this is already too detailed. Is that the problem? No cache needed here, also too big. So in our ranking service, we will point directly to object store, and we will also point directly to SQL database. So this is the high-level design. Hmm. Okay. Mine was too complicated, but in some of the like pastebin, for example, we in the high level overview design, they did not include caching. Okay, so you never introduce caching in a high level overview design. Only important core components. Caching and load balancers, DNS, CDN, all that stuff is when you scale. Okay. Okay. Yep. Okay. Okay. So now so now the point is I'm trying to eliminate single point of failures because this system does work, but it introduces point of failure here. If our service goes down, that's another point of failure here. Obviously, this DB is handling both read and writes. So this is going to have to scale so that we can improve performance and so that our 100 billion reads per month don't cause problems. Okay. All right. So first off, if this is Amazon, we're dealing on transactions on a global scale here. Um, so let's go ahead and start by including our DNS. So this is DNS. I'm just gonna call it, should I call this DNS? It's probably a weird way. That's a weird DNS. What's a good icon for DNS? I like the globe, man. I like the globe. Let's add that. We'll do. This is DNS. Confirm. Okay, so this is our DNS. So client will actually connect with DNS. We are implementing a CDN in this case because this will actually improve performance as we scale, because we do want servers local to where, at least as close as local as possible to where the clients will be sending read and write connections from. So after that, we will then connect to create a circle. We'll call this call this make it like orange. And this is a basketball. Okay, all right, dude. So okay, this is my CDN. So this is my CDN. And then from there, actually, the CDN is what will connect to the web server. So let's do that. Okay. So once the CDN connects to the web server, I think what we'll do, just make this look a little bit nicer. All right, that I guess. So now we're gonna need a multi-layered web server. Uh, this web servers. Get that web servers. So now we're connecting to the web servers, and as far as the web servers are concerned, we do maintain our API gateway. Okay. Ranking service. So we'll now need multiple services. Call this services. Let me. All right, so these are the services. Let me delete that. Bring it over here. This is the ranking services. Hey, what's going on, Akash? How you doing? Oh, and let's not forget the most important thing of all, actually. We need load balancers. Load balancers. These are my load balancers. Let me something like that. So from my load balancers, it will then distribute over to the web servers, like so. And then from the web servers, it will hit the API gateway. From the gateway, it will go straight to DB. And this is where we need to fix these scaling issue. So because it's going to be extremely heavy for just this, and we have 100 billion read requests per month, this is where we need to consider caching, or even maybe not caching, but we can store this in a master slave SQL database. I should also clarify this is going to be a relational database for faster read and writes. So this is a SQL DB. And these are just object stores. Okay, so from here, let me. So first things first, we want a master-master relationship here. So this is. Do we want master-master? We have 1 billion sale transactions happening per month. It would be convenient to have a master-master because we're aiming for here. This is high availability, right? Yeah, high availability. So we're going for eventual consistency. And if that's the case, I do want to offset the amount of load going into this database. So I do want this to be a master master. Master, this will be master as well. So whoops. This will be master as well. And of course they will be sending connections to each other. Of course, we're running into the one main issue. The one main issue being that number one, this introduces complexity, um, because well, this is going to introduce complexity for sure. It's also going to make it more expensive because we're adding another database. But this will, considering we have this many customers, I believe cost is not necessarily something that we're too concerned about. I do, however, want to have read slaves. The question is, do we want to increase complexity with both having slaves or just one tree having slaves? Like one tree or two tree? Um, let me think. I guess they're both gonna have replicas. So let me do that here. So I just called, change this to black. W. Whoa. Whoa, buddy. What the fuck? Replicas. Okay, so as far as replicas, these are slave replicas. Slave replicas. These are only read replicas. I should specify they are read. Oops. Slave read replicas. So having two of them is pretty crazy. In fact, if one is out of sync, it might actually throw some inconsistencies as far as ranking is concerned. So just one is fine, and we'll go ahead and divert that into our read replicas, and the read replicas will just pull from this one. Oops. All right, so it will pull from this master database. But what I do want to also note is that the complexity here is that obviously if this master goes down, we're gonna need to promote one of these to master. So it should be okay until this one gets fixed. Um, as far as sales API, we can divert this to either this one, or we can divert it to this one. So either or is fine. We can just do it like that. So that way we're splitting the load between the two databases. It's less load for them. And reads can go straight here to the read replicas. As far as ranking services, I do have multiple of them. For the object store, we may want to double up on the object store. Because, well, actually, what are we looking at here? 1 billion oh yeah, dude, I mean, come on. Like, this is kind of very necessary at this point. I don't even know how many masters we want at this point. Probably quite a few masters, if I'm being honest. Is this oversimplified? This is kind of what I got going. Does that make sense? Okay. Well, let's check what their answer is. I'm gonna fail this, man. They asked me to code. Hello? Hello? Oh, okay, okay. Come down now. Load balancer, web server. You do need multiple APIs. Sales rank server. Master slave. SQL read replicas. I'm kind of off actually. Only one object store. Multiple ranking service. And then we do need a cache. Alright guys, I'm gonna go eat lunch. I'll be right back.
Obsidian.
I don't know. You just didn't.
It was saving on my phone.
You,
So
you need to remove that
yeah.
auto whatever, autofill your. Well, I don't even know how that's your address.
The 90231, it was the
You have a laptop. Why don't you just start ordering stuff using the laptop?
it's the and how simple did I do that? Like,
You have a laptop. Use.
I put the right address here, put the right street here, and I put 40. But then she's like, "Oh yeah, it is Texas." But then I accidentally went down there, but they said they're gonna send it to distributor in LA. Oh, but she's gonna try to see if she can help me change that.
Okay.
So 4 billion. It's single thousand million trillion billion. So 4 TB times 500. Oh, sorry, 4 times. So each page, say we have 1,000,000 pages, each be 500 kilobytes. We have 1,000 pages. Kilobytes times 1,000 pages is 500,000 kilobytes, which puts us at 500 megabytes. Then 500 gigabytes, 500 terabytes, and then 500 times 4 gives us 2,000 terabytes, which is equal to 2 petabytes. So that's 2,000 TB, which equals 2 petabytes. 2 petabytes. One billion searches per month. We have 1 billion searches per month. So searches per month. If we need to scale, this would be 24 petabytes per year. And this is 72 petabytes for 3 years. I'm sorry, 72 petabytes. And then billion searches per month. Search per 3 is equal to 6 billion. Searches per month. If I divide by 30, that's searches per day. By week per hour. So 1 billion searches per month is equal to billion searches or 400 requests per second. It's a lot. Gonna need a database. Sure. Also need the heck. So that's the database. Oops. Going into multiples yet, just a single server. I think so. User makes a request to server. Web server. We will need API gateway. This is this will be the search API. This will be the I think that's it, really. Just search, right? Don't think the user is going to obviously change the website. So this remains as is. It's read heavy for sure. Very, very read heavy. We will, however, need another service here. This is the update service. Okay. So from here we go to the search API. Search API will then we need an object store. This is where we store all the information about the website itself and all the contents. So search API. Need probably just a relational database. And the reason we're going relational is because I'm ordering them by ID and grabbing them by ID based on the search. We need a search service. So we need search service. Okay, so when the user queries for a specific website, hits the search API, we then end up at our search service. So that's our search service. Search service then basically will handle all the craziness that goes with fetching all the information from the database. And that's the object store. Object store is basically going to house no object store. I think we can just place the object store. So search service will actually hit the SQL database, and then Client web server search API. From the search API, we then hit the service. Service will then query the database for a specific website, in which it will return website. And what am I missing here? So it queries the database, gets the result, sends it back. There is a separate update service. Update service will simply just go through our SQL database and we'll check. Store here too. Goes into our SQL database, which then checks if the websites have been updated and will update properly. Object store. Well, if the search API queries a website that we don't have in our database, we may want to store it here. And the update store, maybe update service will update here. And maybe search API goes here. So search API, search service. What about the object store? Do I need an object store? Yes, this holds all the content. SQL database will just query from the database that contains the file path, because it has the file path here, and the object store itself contains the so I kind of want to say that this will actually gather information from the object store, and then it'll send it back to search API. SQL database houses only the contents itself, or the link, the name, the path. It's kind of unnecessary. So maybe we don't need object store. Maybe we can take this. If we have a search service, point to SQL database to update the service. What else am I missing? So here we have traffic language distributed. Some search terms are more popular than others. This indicates we're gonna have to cache for sure, but that's later. We support anonymous users, so it could come from anywhere, which would indicate that it doesn't necessarily have to connect 2. Web crawler should not get stuck in infinite loop. It gets stuck if it contains a cycle. I literally do not. A queue is needed here. Crawler service, query API. Oh my goodness, dude. User search flow, crawler data. We're using non-relational database. Why are we using non-relational database? Document service, crawler service, queue.
CAP theorem, scalability, latency, durability, security, fault tolerance, compliance. These are all the things you want to consider. But crucially, you don't want to just list those out. The reality is that most systems nowadays need to do all those things. But what you're doing in non-functional requirements is calling out to your interviewer the set of qualities that are uniquely relevant and interesting to this problem, and the things that you're going to prioritize when discussing the interview. So let me paste in a list here of non-functional requirements that we can discuss. So for non-functional requirements, here's some things I want us to discuss. So first off is scale. At this point in the interview, I would ask my interviewer, what's the scale that we're talking about? They might ask you to estimate it, or they might tell you. I'll just tell you here. And in this case, we want to scale to millions of concurrent videos and up to thousands of comments per second per video. So this is going to be a lot. This is going to be huge scale. Actually, there's a fun fact here in the write-up, and that's the most popular Facebook Live video was called Chewbacca's Mom. It featured a mom thoroughly enjoying some plastic, Chewbacca mask, and it had been viewed over 180 million times. And so that's tons of concurrent viewers. We can estimate some portion of them were commenters, and that lead us to these thousands of comments per second. And so the second thing that we're going to consider here is CAP theorem. We considered scale. Now we're going to consider CAP theorem. Now CAP theorem you want to consider in almost any system design. Go as far as to say any system design. And the question here is, do we prioritize availability or consistency? And so the way to think about this, and we have a video specifically on this trade-off, but do you need strong consistency? But in that other way, does every single write or does every single read of your system need to be reading the latest write? And so in the case of our comment creation, does everybody need to see the latest comment immediately when it comes in? And the answer is clearly no. Like, we want real-time, low latency broadcasting. That's what we'll get to next. But it's not an error if that doesn't happen, right? We would rather be highly available. We'd rather you get comments than see no comments just because we can't show you the very latest comment. Hopefully that makes sense. And so in our system, we're going to prioritize availability over consistency as it pertains to creating comments plus reading those comments. And then the third thing we want to consider here is around latency. And so we do, despite our eventual consistency, want to be as quick as possible to broadcast new comments to users. Right? It wouldn't make too much sense if you're watching a World Cup broadcast, Messi scores a goal, and then 5 minutes later, people are commenting, oh, Messi, what a goal, right? You want to see those comments come in almost immediately. And so we're going to actually quantify this. And we're going to shoot for about 200 milliseconds. Another fun fact, 200 milliseconds is what we as humans perceive to be real time. So if you're in an interview, it means real time. 200 milliseconds is what you're striving for. Anything lower than that, frankly, it doesn't matter. Humans won't perceive the difference anyway. And so last thing that I'll say about these non-functional requirements is that aim to quantify them where possible, like we did here, and always put them in the context of the system. So availability greater than consistency, meh, not that interesting. But for comment creation, okay, I understand why. Saying just low latency, meh, of course, but what specifically? In case comment broadcasting. Same comments about out of scope or below the line. Security and integrity are two things that are often important to live comments, making sure people aren't saying bad things. It's not something that we're going to focus on in this particular interview. Zooming back out, we can see our next steps are to define the core entities. And we can do that now. The reality is that these two parts of the interview should move pretty quickly. Particularly in this interview, they're not overly interesting or difficult, so we should be able to get them down pretty quickly. Let's start with those core entities to make this as easy as possible. What are the core entities of the system? What are the nouns of the system? What are the tables that we're going to have? These are all ways to think about this. Well, most importantly, we're going to have comments, certainly. We're also going to have a live video. Now, the actual data model for the live video, where it's stored, this is out of scope. This is another team that will handle this. But it's important to recognize as an entity because we're going to have relations to it. So I'll write it down anyway. And then we're, of course, going to have a user or so those are our core entities. And we can then move on to our API and use those core entities to shorthand our API. So when you get to the API, The easiest step-by-step formula here is to just go back to your functional requirements and go one by one through your functional requirements, making sure that you have an API to satisfy each of these. Now, this isn't 100% foolproof. For non-user facing system design interviews, something like a design or web crawler, this doesn't make as much sense. But if it's a product, if it's a user facing product, as live comments is, then this is a nearly foolproof way to do this. And so some functional requirements may require more than one endpoint, but the process remains the same. Go one by one through your requirements and create the endpoints necessary for each. So the first thing is viewers can post a comment. Okay, great. We're going to use a REST endpoint, and we need viewers to post a comment. So we'll get that endpoint. It's going to be a post because we're creating a new resource. What is our resource name? It's comments. Some of you have picked on me in the comments for not pluralizing my resource names. So the reality is, to me as an interviewer and to most people, who cares? But proper RESTful semantics say to pluralize a resource name, so I've done that here for you. And then we need to know which live video we're posting this on. So I'm going to use a path parameter here and pass in the live video ID. Now, why not put this in the body? Well, you absolutely could. But given that it is required, you cannot possibly create a comment without a live video ID. It's common here to put it in the path parameters. So that's what I've done here. Now, what does this return? It can either return the comment or 200. What's the body? Well, the body is the comment itself. And notice I'm not getting caught up in the details of like what is a comment at this point. Of course, a comment is going to need to have some content. If there are extensions here, then maybe we'll have media attachments, which we're not going to handle. But I'm just abstracting this for now. And it's just a comment. It's the core entity that we've defined as a comment. That's what it's the post body there. So we checked off one of those functional requirements. Let's go back up and look at what our next one is. Viewers can see all comments posted in near real time. So astute viewers are thinking to themselves, wait a minute, this is going to be a WebSocket or some persistent connection. You're right. And if you know that this early in the interview, go ahead and write it down. That's fantastic. I'm going to take the approach of assuming that we don't know that. Or even if we do, we're just going to build things up simply. And so the simple way to do this would be that we're just going to have some get endpoint. We're going to have some get comments endpoint. Sheesh, this is why I don't type in front of you guys like this. Get comments endpoint, which takes in again that live video ID. And maybe it's just going to take in a cursor. So this is basic cursor-based pagination. And we'll be able to pass in the last comment ID that we saw. And this is going to return to us any new comments that have come in since that last comment with some page size here. Okay. So if you don't know about cursor-based pagination, fairly straightforward. You're just going to pass in a cursor, which is the ID of something in your database, some row in your database. And then we're going to get everything after that. And so that's what we're doing here. We're going to get 50 comments after this. And so we can just be calling this over and over again to simulate some sort of real time. We'll talk about that in design. And of course, this is not the optimal solution. It's not efficient. We'll do something better. But at the early phases of your interview, even if you are a SAP candidate or something, it's okay to put this down for now. And you can just acknowledge this is going to expand. This is probably going to use some something persistent later on. And so the next one, viewers can see all comments posted before they join. Well, this is essentially the same thing, right? We want to get all the comments for a live video, but instead of it after the live comment ID, we want it before the live comment ID. And similarly, we want a page size, like maybe we want the 50 before this point in time. And then if we want 50 more, then our last comment ID will be updated to the last of that 50 that we just got, and we'll get the next 50. You can see how that's happening recursively. But the difference here is there's a direction. In one case, we're going past comments, and in another, we're going future comments. And so what we can do is we can just add that direction pretty simply to our API. Do we want after, or do we want before? That's a way that we can follow. So there you go. 2 basic REST endpoints, one to post a comment, the other 2 to get comments. I'm using basic query parameters here, denoted by the question mark for the first variable, posts, gets, all pretty straightforward at this point. So zooming back out, we've done our requirements of what
Am I getting any interview calls? What's going on, Shreya? Yeah, so not from Red Hat, but I am interviewing at um so I'm interviewing at two other companies this week, and I am onboarding onto a contract role, but to be fair, it would be a dream to work at Red Hat, so I would hope that, they move forward. I think from when I applied, I have not received any updates yet, but it looks like I can track my application in the portal. So let me just do that really quick. I don't even know that's where it is. Forgot my password already. That is not ideal. Thank you for reminding me. Let me check right now, though. 14 characters. Okay. Yeah, looks like my application's still in progress. So yeah, no updates um, as of today. But fingers crossed for sure. They reposted their full stack position in Raleigh, North Carolina. My assumption is possibly that it's a on-site role. Yeah, it's hybrid. It's hybrid. So, yeah, it's very likely that they probably will not, well, this one is hybrid. So they probably won't even bother with my application since I don't think I can move. I would like to, maybe, but I don't think my girlfriend would be too happy about it. Yeah, that's unfortunate. Oh well, I mean, I appreciate the help no matter what, So, thank you either way, for sure, for sure. Uh, Start with some functional requirements. Let me just zoom in a little bit more. So, functional requirements. We have one, managers can post, can update questionnaire to employees, can respond to questionnaire. 3, managers can respond to questionnaire. What else? This is going to be a manager employee management portal or management system. So this is what we're building. Okay. So these are our functional requirements. This is management system. Managers can update questionnaire. Employees can respond to questionnaire. Managers can respond. Respond to questionnaire. Managers can update questionnaire. They can respond. And I want to say number 4, managers and employees can view previous updates. Functional requirements. This is strictly for updates feature. So we should specify that this employee management system is actually a system that includes managers, employees, they manage employees profiles, employees profiles. It can also both employee and managers can schedule meetings with others in team. Others. Both users can check and respond to feedback provided by managers. And both users can check. I think that's it. I'll keep it pretty simple. So this is the system we're building. Okay. We can now say that this below this is the oops. This is this. This is okay, so we want to say schedule meeting, or just say users can schedule meetings. Users can provide or respond to feedback. And users can create / alter profiles. Okay, so this is our functional requirement. These are non-functional, so we'll focus on this and do this later. So now is where we define this is below the line. Oh, I see. And then we do have a separate we have non-functional one scale to you can scale to millions of you can scale to millions of users with hundreds of thousands of responses per second. Why is this non-functional requirements? Think users decision makers. Is it considered non-functional? This was posted 4 months ago, so I'll just stick with it, I guess. If the interviewer asks me that this should actually be functional, okay. We do want to make sure this is a highly available system because neither user honestly needs to see the feedback right away. We do want it to show up quite. Oh, and there's a notification system too. So I can say that notification system or service for schedule schedules scheduled meetings slash like responses slash updates. Okay. Something that's highly available over consistency. In general, that's what we want. And then as far as latency, going for course, everything should be. Do we want low latency? Yeah, right. Does everything have to be low latency? For the responses, it's not live, so we don't really care about low latency. I mean, moderate latency should be perfectly fine and potentially reduce the amount of resources we need to rely on. This is a write heavy application though, so this is a write. So I would ask normally, but this is, they don't provide that information. High level design, he goes straight into high level design, then deep dive. And it's straight deep dive until he scales the system, and then that's it. Scale to millions, 100,000s of responses per second. To millions of users, 100,000 responses per second. So a generic millions of users is fine. Don't need like a specific number. I'm assuming behind the envelope calculation generally not needed. So I can clarify if that is needed, but I'll assume most people don't do it now. Okay, so we have available risk consistency. We do want to make sure there is, what's another thing?
Next, let's talk about latency.
Okay, eventual consistency. You can literally say eventual consistency. So eventual. Well, I mean, that's already said. That's what I said already. I said we're looking for availability over consistency. In other words, this is actually eventual consistency.
Users expect responsive UIs, which means we have a few hundred milliseconds to respond to requests before they start to get annoyed. Let's use 500 milliseconds as a round target latency for both posting and viewing.
So 200 milliseconds is what we perceive as instant. 200, this is latency. Perceived instant response. So if we're not looking for instant response, I suppose a 500 millisecond latency is fine. Posting and viewing, okay, yeah, for commenting and viewing. So that's what I'll say. We have another he calls it bonus now though. I just call it bonus as well. Dude. This is okay. Security. What's he say?
Now let's think about scale. Knowing the scale of a system will give us more bounds on size and throughput we can use later. Facebook is big, billions of users. We don't need to know exactly, so let's just assume 2 billion users and move on.
Okay. So now we're at the API. So for the API, actually do this. Create the API here. So this will be API for post. For this, managers can update questionnaire. This is a post slash update. update ID, and then we have an update ID. We include this is the API. So and then we just go straight to the body. So assume this returns 200. The body of this would just be the new like questionnaire. Think I actually want to include a couple things here. We do have core entities, which include the user, manager, questionnaire, which includes the questions itself and the replies.
Hello? Yeah, what's up? Are you serious? Oh my god. Okay, well, do you want to get it back to our house? Sorry, I'm back. We just tried to rescue a husky, but it looks like the situation is a little bit crazy. Um, yeah, the husky was abandoned by their owners. Um, but yeah, I think husky has like fleas. Um, very skinny, very skinny. Um, it's a male husky. But yeah, it's kind of it got attached to I guess one of the neighbors. So when we tried to put the leash on him and tried to take him to our house, he didn't want to go. But yeah, we're just hoping that the I guess the neighbor that takes care of that husky sort of takes care, like not really completely. I don't know the neighbor that abandoned their husky. We don't even know them, but the husky's like skinny, not taken care of, definitely has fleas. Um, like it's like it looks like it's starving too, but it didn't want to eat any of our snacks. So we were willing to kind of like take the husky with us to kind of send the husky to the vet, get the flea work done, send and then also kind of groom him and give him a shower, but he just wasn't willing to go with us. So we decided to just let the neighbor that's kind of taking care of the husky right now, just like loosely taking care of the husky, not actually taking care of the husky entirely. But he's like feeding him, and the husky likes to sneak out of his backyard and roam the neighborhood. But the problem with drivers here is a lot of them drive drunk. And there was another accident that happened down like along the street where I guess someone hit two trees. And you can see the car parts just all over the floor. So I'm just hoping this dog doesn't get hit by a car because that'd be pretty fucked up, honestly. Yeah, I don't know, man. Yeah, no, that's why like we wanted to rescue that husky, but he just was not willing to go with us. And we didn't want to force him to go to our house, like completely new environment. He's unfamiliar with everything, and we can't bring him into the house either because he obviously very likely has fleas. Plus he hasn't been showered, so the dog is like dirty. So us being like a very clean family, it's yeah, we can't take him in now. We would have to. Yes, Leo. You almost got a brother today. You almost got a brother today. Also, here's the thing. If we were to have two huskies, we would have Leo, who's a male, and then we would have this new rescue, which is also a male. And from what I understand, two male huskies usually don't go well with each other. They tend to they don't I don't know. From what I've heard, male and male dogs usually try to like alpha each other up. So yeah, I don't really know what we're gonna do with the other husky. But the neighbor that's loosely taking care of this husky, since the dog was abandoned, he said that if he's willing to come by, visit the dog, and like, you know, um, get closer with the dog, and the dog's willing to go with us, then he's fine with us taking the dog, I guess. But yeah, you just see the I should have taken a picture, but where the dog is sleeping, it it's like, are they competitive? They could be. Um, and Leo's usually the one who's used to being the only dog in the house, so bringing in another dog and having to split that attention might make him jealous for sure. But the point is, this husky that's been abandoned, he's like in front of the owner's house, like the actual owner that abandoned him, and he's sleeping on a piss-covered dog bed, and there's like flies all over the place, and man, the dog is dirty. Like he needs and like he hasn't been groomed, so he's got like thick like fur that's just stuck there and it's about to come off, but oh man, dude, that's a sad state to be in. And also like it's getting really hot here in Texas. Like really, really hot. So we're about to hit triple digits. Like he can actually die of a heat stroke if he's not kept indoors. So like I don't know, man. Yeah. Like the dog in the next I think monthly weather forecast. So see, it's already hitting 90s. I mean, we're easily. I know these numbers probably don't make sense because they just go up by one. But I think in late June, potentially even early July, we might start seeing like triple digits, and the husky's gonna fucking die, dude. Like this type of weather is not. This type of weather is not suitable for a husky. Like they're bred for, being in cold environments and they're work dogs, Like they're meant to like pull sleds. Um but yeah, dude, the dog's gonna die of like a heat stroke or something for sure if we don't do something about it. Apparently he's been abandoned for I think at least a couple days now, like maybe like a week. The neighbor isn't actually helping. Um, the neighbor said that he tried to give the dog a shower, but the husky wouldn't accept the shower. He's putting out food to feed him, but I'm assuming he's in like maybe he's in retirement or something. So he it's not like he has enough. I don't know if he has enough. I don't know, man. I don't know what's going on, but that neighbor is, like I said, loosely helping, not fully helping. And I think his son wants to keep the dog, but the dog won't let him do anything. Like the dog won't let them groom him. He growls and gets a little bit aggressive. So, um, yeah, it's a very weird situation, I would say. Hello, hello. Yeah. What? Dude, how do drivers here not know how to drive? I don't understand. 5-car collision. Was everyone just tailgating each other? That's crazy. On the side, yeah. Oh, that's crazy. All right. Well, drive safe. Don't go crazy. All right. Yeah. Okay, bye. Um, shouldn't the dog be taken to a vet? Yes. But here's the thing. I think a lot of dogs are not a lot of people aren't willing to take the dog in. So right now he's kind of ownerless, right? He is an ownerless husky. He's being supported by the neighborhood, or by the neighbors that know this dog has been abandoned, but no one's actually taken him in yet. So I don't mind taking the dog in to see if he'll work with Leo, but he definitely needs flea medication and flea medication and like at least to be groomed so he's clean. And then we might need to buy something to like prevent him from going upstairs because I would rather him like if he is gonna have to be potty trained, I would rather him, you know, not urinate and poo in the house and stuff like that. How come the webcam moves all the time? I don't know. It's just the Apple thing, I guess. I don't know, man. That's crazy. I heard Husky and I was like, we will go try to rescue the Husky, but he didn't want to come with us. You could argue that we could have just tried to force him to go with us, but I think he would have started biting the leash or something. Hmm. True. Yeah, but the thing is also it's raining right now and we don't have a extended patio. So he would essentially be stuck in the rain the entire time we took him in. So until we get him like groomed and remove the fleas and all that stuff. Yeah. We did exchange numbers with the neighbor that's kind of like overseeing him right now. I don't want to say taking him in or the neighbor that's supporting this dog. Um, so we'll I think we came to the conclusion that we're gonna stay in contact with this guy who's kind of like just making sure he doesn't die, and then um he said that if we want to come back and like build a relationship and maybe see if we can get him to be more comfortable, then if we can take him, we should be able to. That'll be fine. How is the neighbor feeding him? He just puts out like a little bit of dog food outside, and then as far as like the heat, I think his wife puts like ice like they give him water and they put ice in the water and they try to like groom him, but like I said, he doesn't want to be groomed. Or he did groom him, but then he realized like, damn, there's just so much fur. So I think they're still on the fence, but the neighbor that's watching him right now, like I said, the son wants to take care of the dog, but they just can't get the dog to do anything. So that seems to be their main issue right now. And yeah, we're gonna remain in contact with them. So I mean, we'll see where it goes. If we do end up taking care of the dog, then we'll have twice the amount of fur and twice the amount of poop. Yep, for sure. Dude, I know. I know. I don't know why they abandoned their dog, but it's kind of sad because the dog sleeps. He usually stays in that other neighbor's backyard, but like I said, he'll escape pretty often. And what he'll do is he'll go back home to the original owner's house, and then he'll just sleep in the front door. So it's kind of sad. Yeah, I don't really know what to do yet. Yeah, it's crazy. I'm just worried about like the heat. Like the dog is gonna be in a really bad situation when it gets really really hot. Yeah. I don't know. There's some really questionable people out here in this world. My guess is they were renting the house and not owning the house, and they must have defaulted on their payments, so they basically were gonna get evicted. They probably just got evicted, honestly. They packed up all their shit, they left all their trash at the house, and yeah, I don't know. It's crazy. I mean, to be fair, Texas infrastructure kind of sucks. That's just my opinion, though. Um, question. And then question. How do you? Do I think I'll still live in Texas for a long time, 20 years, or leave for a different state? I don't know yet. I'm just kind of going day by day right now. Haven't really gotten that far yet, I guess.
Next, viewers can see all comments posted before they join. This is essentially the same thing, right? We get all the comments for a live video, but instead of leaving after the live comment ID, we want it before the live comment ID. And similarly, we want a page size, like maybe we want the 50 before this content comes.
Partners in GTA 6? What do you mean by partners?
To the last of that 50 that we just got, and we'll get the next 50. You can see how that's happening reversibly. But the difference here is there's a direction. In one case, we're going past comments, and in another, future comments. And so what we can do is we can just add that direction pretty simply. Or do we before? That's what we can. So there you go. Two basic REST endpoints. One to post a comment, the other two to get comments. I'm using basic query parameters here. Question mark parameters here. Posts, gets. All pretty straightforward at this point. So zooming back out, run these already. This is kind of the general set. This point we've agreed that with our interviewer what we need to do. We've set our parameters, our foundation, know the general download the interface. And this is where things get fun, they get interesting.
Oh, romantic partners? Probably.
And so just like
I don't know about online, but for sure the story.
we're going to just satisfy our functional requirements. And we can do that by going and so if we go one by one.
Dude, when I was young, I played any game I wanted anyway, so I don't think that matters. Plus, you can just download them without parent consent.
And so I'm going to go a little bit quickly through this high level design. Reality is the high level design for this system is really straightforward. And I want to set out to go deep on things that are interesting. So let's talk about what it might look like. So the first thing is the user is going to be able to post a comment. We have an API for that. Post comments. Cool. That's small. The second, so the first thing is that you're going to have a client. I'm going to introduce an API capability. It's not strictly necessary here. It's a single client server database relationship with your client. So we don't need to go but I'm going to take advantage of it and introduce it. Also going to have a comment service. So this comment service is going to be responsible for comment operations. And need some way to persist these comments. So this is my comments theme. And so what's going to happen is the user is going to make that post request we create a new comment. Our API gateway is going to forward that on to the comment service. Comment service is going to craft and initiate a query to our comments DB in order to create that new comment. And so we talked about earlier in our core entities, we're going to talk about the data model or the schema just yet. Now is the time where we get into our high level
facial recognition lies issues lies. Yeah, I guess probably.
And naturally, what is a comment? A comment's going to have some comment ID. It's going to be important. It's going to have the video ID where this comment is placed on. It's going to have the anchor ID. And then it's going to have the contents of the comment, the text of the comment, with some created at field necessary. And so in terms of our query pattern, we're going to be querying by video ID alone. So we want to index on that. We're also going to be sorting by the created at column as well. And I'm not going to make any decision about the type of database yet. In your interview, it could go either way. You could talk about it now. That would be totally fine. I'm going to choose to talk about it when we talk about scale. I think it's going to be more interesting. The reality is, for a simple high-level design here, any database is fine. SQL database is fine here. MySQL, instead key value stores, document stores. So I'll go into more detail. But important to know where your index is, what your primary keys would be, of course, in this case. So that's the thing first. But very simple. Find initial the data. Check. Viewers, simple code. Next up is the viewers can see all comments posted in real time. Now, of course, as we alluded to earlier, this is going to require some persistent connection. You'd be wise to layer in your comment. And I know this is going to require some persistent connection, but let me start with the simplest thing that we could do. The simplest thing that we could do is that basic pull.
Persistent. For the update service, post update service. And change questions service. And go to database. And then go to our database.
So for a high level design, I would say pretty simple. We either read the API or we write the API. If it's a read, high level design, just go straight to the DB. For a write, we have to connect with our update service. Then we connect to either post, so then we'll either connect to the post service or we'll connect to the change question service. And then both of them either will hit the DB like so. Okay. Something like that. As far as the database that we're concerned with, if it is housing just the updates in this situation, I believe just a SQL database would be fine here. And the reason for that is simply because the relationship between updates is not entirely too complex. I mean, we literally just have the what do you call it? We just need to reference the updates ID and also the user ID, of which, you know, if the user ID is managed by someone else in another database, this will just contain updates ID. And based on that, we can just query for that specific ID, which is pretty straightforward. Let's say here, updates, we have update ID, we have, of course, the question number. I think I just change this to question number, because it'll just be an array, really. It doesn't need to be like anything crazy. Although I guess maybe, yeah, question number will either be like 1, 2, or 3 or something like that. So maybe question ID and then slash number. So we can contain just like question like index or the number associated with that. We also do have the user ID of the user that is referencing. I think that's it, right? Have I played Oblivion Remastered? Oh yeah, I did play it for a little bit. If you think it looks better than Cyberpunk, then I have bad news for you because I think Cyberpunk actually looks infinitely better than Oblivion Remastered. But maybe you're talking about like artistic style. You'll be taking your leave here. Thank you, man. I appreciate it, bro. Thanks for stopping by. Let's assume in this case this DB houses users, right? Maybe not necessarily just the updates. If that's the case, then we may have like users they have the questions, which is something like that. Then we have, of course, user ID, which is a probably, considering, you know, we don't have that many users right now, just an int is fine. Aside from that, maybe there's like a manager, user manager relationship. User may have like employee manager relation, which I think we can also just store that in probably something simple. It will be ID to ID. So if an ID is an int, it'll probably just be like, I don't know, just another int or something. This will be an object. Questions is an array. An array can be, it's debatable, but it's an array of stuff, of questions. Question one. Oh, these will be updates, and updates contains updates is a, oh, maybe just wizards and medieval setting. Yeah, probably. Cool, thanks, man. All right, well, I'll see you next time, bro. Take care. Thank you. Updates. Each user will have updates they can view, which would be a collection of questions. So updates itself contains like questions. Oh, they have like question, and for each one of these we would probably have maybe like the question, and inside this question we do have a updates. Updates contains question one, question two, and the responses. So this could be the questionnaire, question, response, contains question one. Something, and this would be, oh, I'm so fucked. Question is text, which can be maybe, I don't know, can be like varchar 255. And then it contains a response char 255. Obviously the user has a user profile picture, which I would say maybe 56 kilobytes roughly should be able to handle that. So we have the response plus and then, you know, so on and so forth as needed. So this is kind of how the structure looks like. So go by, this is a no SQL DB. That kind of makes a little bit more sense here. So updates as a questionnaire. This is kind of redundant, so I'm gonna delete that. But basically, it looks something like this. Okay. So I have confirmed I will be going with a NoSQL database. Just because it makes sense to me.
API that we outlined here. So get comments for a live video ID, instance some given last comment for video. This could also be a but in any case, what we do is then just have a simple client.
Oh, not only that, we do also need to consider that users updates contains char question as well as date, which is a date, roughly like 5 bytes here, int will be like 4 bytes here. Likewise, same here, we got about 4 bytes.
It's going to every 2 to 5 seconds gateway to ask our comment service if there are any new comments since the given comment ID. If no comment ID is given, well, there's no comments. That query is simple. That query is simple regardless of what database you chose.
So how this works is the client basically, if they want to read, will assume that we'll fetch the we'll query the database and see if the user contains any updates within their within the updates table. And in this case, obviously, if there are no updates, then we just send a response back saying there are no updates to post. Maybe they just joined, and that could be, you know, one particular case we handle that. In the other case, let's say the user decides to either write the IP, decides to call, like maybe they want to actually post something, in which case they will handle this through our update servers, and depending on which direction they go. For example, if they want to post a response to a specific question, then the obviously we have a available updates object and it's not empty anymore. So we'll query the database, send it back, and then we'll reach the user so they can actually post the response and they can then see the update once the API updates. So we'll post the response, we'll show it for the user on the user interface side of things. The database will update, and then of course if the user refreshes the page, I mean it'll query the read API, go back to the database, and it will show them the updated information. Likewise, let's say maybe the manager wants to go ahead and update the questions in the questionnaire. So they'll hit the update service, query our database, be provided like a form, in which case they can then update, you know, questions. They can actually add questions, and this will then populate, obviously, the questions response. And I suppose we can actually say that these are question response, yeah. So this is the question response. By adding more, let's say in the next week, you know, we decide to update. Well, let's say for the sake of our users, we also don't want them to have to need, at least for the managers, they, let's say they post a question, they want to reuse that question. They may have an option to just automatically add questions. In which case we may just have our post post response server change questions. Whoa, what in the world just happened? We may want our another service actually. So let's go ahead and create another service here. This is going to be independent of these two services because it will be a toggleable option when they change questions. So inside questions, they may have the option to, when they're provided the form, they can toggle to repeat this for permanently. So given that, we can say this is auto update auto populate questionnaire, and this is a service as well. So if they toggle this, then we'll actually just go ahead and say that this ends up hitting this service over here. Oh my god, this ends up hitting this service, and the auto populate will actually just naturally populate the next set of questions for the manager, only if the manager has it. So we do have two issues here. Obviously, we need to determine if the user is a employee or a manager, because somewhere along this update service, only managers are allowed to actually handle this portion of things. So given that, how would I do this? So given the situation where we essentially saying the update service itself here will verify if the user is either manager or an employee, and then it will send them in. It'll probably be like a feature flag here. So I would say maybe there's, yeah, maybe we can put something here. This is like a user. This is a employee manager feature flag, something like that. And that way, is it employee manager feature flag? And then, so obviously, once this update service hits this, then actually, what am I doing? Just go straight here. Then it will, depending on what's available, they will either allow them to post a response, or it'll allow them to actually change, which will auto update and so on and so forth. That makes sense. Okay. So this is the high level overview.
SQL database, this is simply select all comments where video ID equals the given video ID, and create is greater than the created cursor. Fine. And then similar query if this is a document store, key value store. This query is pretty straightforward regardless of what database you choose. So if you chose a SQL database, then it's just select all comments where the video ID is the given video ID, and the created at time is greater than the created at time of the cursor or the last very comment. Nothing to it. Similarly easy on the document store. Awesome. So again, we're just expanding this basic CRUD service. We can create things, we can read things, nothing to it. We're going to use polling in order to just get new comments every couple seconds, and those will be maybe not quite the near real time we're looking for yet. Again, persistence, connections will be important later, but it's a good start for now. Next thing viewers can see our comments posted before. And so we have the same API endpoint, we just specified the direction, and it's the same concept here. So when a user first joins the live video, they have no comments, they have no past comments, and they have no new comments yet. We're going to probably first load up that live video alongside the last 50 comments or so from the video. And in order to do this, we'll use that same API endpoint. We're just going to switch the direction. And in our query, that's just going to switch the greater than or equal to on the create that sign. So now we want the last 50 comments that are less than. And obviously, we're not going to necessarily have a current comment right out of the gate. And so if that's the case, we'll just start at the end of all existing comments. Similar concept there. Now, one thing that I'll note just for fun, but this wouldn't necessarily be the most important thing in this interview, but there's different ways to handle this concept of a user continuing to scroll up. So you've probably done this on Instagram, Facebook Live, whatever it may be, where you scroll up and it fetches the last 50, and you keep scrolling up. And you want to just scroll up and up and up and up and up, and again. For whatever reason, you continue to scroll up and read comments. And there's different ways to optimize this. One really popular thing to do with pagination is to introduce a cache. And this is going to be a cache for a specific user ID, and in our case, live video ID. So that'll be the key, and then it's going to be the comments as a list here. And so when we caches comments, we might show them the last 50, but we're going to cache the last 1,000. This is going to have a really tight TTL. Maybe it just has a TTL of 5 minutes. That's what we anticipate being.
Smell like Charlie?
No, I don't know. I washed my hands. So oh, he didn't smell Charlie though. Maybe he's getting jealous.
Ouch!
Go grab it from their cache.
Ouch!
Now, what you might be thinking is that
It's like-
You think Leo would be happy if he got a brother?
The question is, are they gonna get along?
Yeah.
But it does seem like Charlie's not an aggressive dog though.
Yeah.
It just reminds me of Leo, when I first saw him.
So skinny,
Yeah.
please.
But he looks bigger than Leo. Look, you see it. Maybe he's a little pup.
His paw is kind of small. Right?
Leo paw is small, but Charlie is big.
Not as big as Dollars.
I know, but still.
No, you're making him upset.
Oh, it's so good. No, it's so good. Look, get started on my. Can you give me a kiss? Can you give mommy?
I'm going to let you finish. You see that?
Can you give me a kiss? Okay. You really want this? Huh? You really want this? Being aggressive, Leo. He's upset. You're not scared anymore? Go.
We can give them thousands and let the client just show them the ones that matter. And there's different optimizations here. And this really would only matter for super popular videos where comments are coming in like crazy and somebody may want to be scrolling up really quick in order to fetch the next group of thousands of comments or so. Another pattern that we could do, again, just because it's interesting, pagination here, not specific only to this problem, is that we can have it be such that we send the client over maybe the 500 last comments, and then once the user scrolls up to about the 400th, then the client is going to know, let me go optimistically fetch the next 500 because I have a feeling they might finish this list, finish this step. Something similar to what we do in Tinder. If you've read that breakdown or seen that video. So I'm not going to include this because it's not the focal point here. In design FBLI comments, if anything, I would just briefly comment on that. Wouldn't let myself get distracted because despite how simple this high-level design is, and it is quite simple, basic CRUD service, it satisfies all of our main functional requirements. And it's left me plenty of time in the interview now to talk about the things that are going to be interesting, which are going to be these non-functional requirements around the scale and how to ensure its low latency and eventual consistency. All right, behind those, it's time for everybody's favorite part, which is the deep dive. So again, the deep dives, we're just going to go one by one through our non-functional requirements and expand on the simple high-level design. in order to make sure that we met all of these requirements. At the end, we're gonna be able to look back and say, okay, I met all my functional requirements, I met all my non-functional requirements, I aced this interview, give me the offer, and life's good. Right? So that's our goal here. So first off, one thing that I want to mention is the level to which you're proactive in the defense is a function of your seniority. And so if you're a junior or mid-level candidate, this might actually shift now to where you're less leading the interview and it's more of a question answer. So the interviewer might be asking you questions. You know, this polling approach isn't going to give us the low latency requirements we're looking for. What else could you do? Right? For example. But if you're senior, especially if you're staff, the expectation is that you identify where the issues are and you drive the conversation towards these things. And again, the best way that you can do this is just by going one by one with non-functional requirements. So let's do that now. I'm actually going to go in reverse order here. Maybe I'm going to start with low latency comment broadcasting. So this is the case where a new comment came in. It should show up on everybody's client quickly. As you remember, we're using polling right now. So we just have the client every 2 to 5 seconds asking if there are any more comments. Of course, this means that our latency is 2 to 5 seconds as opposed to the 200 milliseconds that we've been looking for. So we're going to want to find a way to speed that up. The key insight is that instead of using HTTP request responses here, where the client is saying, are there any new comments? And the comment service is responding and referring the database. We need some sort of a persistent connection here. So we need a way that we don't have to ask every single time, but instead the comment service can just tell us as soon as a new comment comes around. So there's two popular technologies to handle this persistent connection. The first is WebSockets, and the second is SSE. And so let's talk a little bit about each of them. I'm actually going to paste in some notes here again to prevent you guys from watching me struggle while typing. Starting with WebSockets, WebSockets are bidirectional. And so you create a connection like this, and now at any point the client can say something to the comment, but the comment service can also say anything to the client at any point. This is great. And so in our use case, you can imagine a new comment gets created or saved by somebody else, and we just push over that WebSocket. It's a push instead of pull back to the client to say there's a new comment, and we can do this quickly. So this is great, and it's a viable option. But WebSockets also have some downsides. So WebSockets use their own protocol. They're not over HTTP or HTTPS. And this just means that they're a little heavier weight. What happens is that they initiate an HTTP handshake first, then they need to upgrade the WebSocket connection, and you need to have all of your infra in between all of these places support this upgrade. And so, for example, the client's going to go to the API gateway, try to do a handshake, establish a WebSocket connection here, right? And then likewise, it's going to go create a WebSocket connection here so that it can sort of be a pass-through. But in the case where you have load balancers, proxies, firewalls, or any of these things that don't support WebSockets, things are going to break. And this happens more than you would expect, actually. So oftentimes, if you're putting WebSockets into production, things are working in your test environment, everything's great, you put it into prod, and you realize that either it's not working at all or it's not working for some users. And this might be because some users are behind a corporate firewall that's not going to allow for these WebSocket persistent connections. It could be that you have some production API gateway or otherwise, which isn't going to support them. And so there are plenty of API gateways that support it out of the box. AWS managed API gateway is an example.
Am I gonna make a TED talk?
Configurations.
That's funny.
So this is by no means a task that cannot be achieved.
My TED talk is so oversimplified compared to this.
And the main kind of interesting bit here, maybe I'll write this down.
This is my TED talk. Guy says, "Yo, wanna post some shit," then gets sent over here to write some shit. Then we go over to update some shit, and this update shit says, "Nah, bro, you a manager or you an employee?" And then it goes, "All right. Well, if you use a employee, you can post some shit, or if you're a manager actually. But if you're a manager, you can change some shit. And if you change some shit, you can query the database, or you can allow for the auto-populate questionnaire service shit, which will just update the database with the relevant user or manager questionnaire updates, question stuff. So I don't know, super oversimplified, but that's probably how I do my TED talk. Hell yeah.
So WebSocket's perfect for when it's bidirectional. There are as many reads as there are. So the client needs to get as many things as it needs to send or post. And so in the case of a messaging app, this is the last video we did. Check that one with Steph WhatsApp if you haven't seen it already. But in the case of a messenger app, this is perfect because there's likely a pretty close relationship between the amount of messages you're sending and the amount of messages you're receiving. But that's not the case here with live comments. The overwhelming majority of our users are going to be in a live video, watching a live video, and then the comments are just streaming in. Like the average here might be 1 to 1,000 or so. You can have some users who are active commenters, but the majority are passive. They're just watching. And so it's not bidirectional. We can still post a comment periodically with our RESTful API that we have with this slash comments post request right here on this HTTPS endpoint. We can receive comments via that persistent connection. And so WebSockets seem to be a little bit of overkill. So what else can we do? The other thing we have is pasted up here, SSE. It stands for Server Sent Events. And this is actually perfect for our use case in live comments because it's similar to WebSockets in that it opens up this persistent connection, but it's unidirectional. And so in this case, it's just the case that the comment service can push changes to the client, but the client can't say anything to the comment service over this. And so instead of having its own protocol, like WebSockets do, it's just over HTTP and HTTPS. And so it uses HTTP headers in order to specify that, hey, I'm going to be sending this over chunks, so keep this open. And it basically just looks like a long-running HTTP request. The other nice thing about this is that it doesn't require anything too fancy. Like browsers have built-in support to handle the reconnections and everything that go on here if for some reason you were to get disconnected. And so it makes it much more lightweight. And then given that we only need unidirectional communication, right choice for us. Of course, you can still post a comment. You're just going to post the comment over the HTTP request response by our post endpoint, which was this guy up here. Okay. So hopefully that makes sense. Now, not all API gateways similarly support SSE out of the box. So there are still challenges here. Many of them will like close your connection after a predefined period of time, and you need to go in there and update their configurations in order to elongate that or specify different headers to make it clear to the gateway that it shouldn't sever the connection after say 30 seconds or 60 seconds. So by adding SSE, it doesn't solve all of your infrastructural challenges, but it definitely makes things easier, lightweight, and we get the unidirectional communication. So let's tie that together. I'm going to just, by way of an abstraction, draw a line through here. Technically, as you saw, it was to the API gateway and the API gateway forwarding to the comment service. I'm going to choose SSE. And I would say as much in my interview, I would weigh the trade-offs between WebSockets and SSE as we just did, and I would come to the conclusion SSE is best.
Oh, I'm so fucked for this interview. Does that work the same for swearing? Or you're still being monitored like a toddler? No, it's fine. This is not a G-rated stream, so you're fine. I mean, curse to your heart's content. Within, you know, control yourself, but curse to your heart's content.
Oh man. Oh man. Let's create a new one. Give me a second.
WebSockets build real-time features by establishing a two-way connection between a client and a server.
I mean, do you want to try pasting a link or try swearing and stuff?
In an online multiplayer game where the leaderboard is constantly changing on the server. Now, what's the best way to show the player an updated leaderboard? We could tell them to refresh their browser window every few minutes to send a new HTTP request, or we could use an interval that ticks every few seconds to pull the server for new data. But these options aren't ideal for real-time data, and that's where WebSockets come in. The first step is for the client to send an HTTP request to the server asking to open a connection. If the server agrees, it will send a 101 switching protocols response, at which point the handshake is complete. The TCP IP connection is left open, allowing bidirectional messages to pass between the two parties with very low latency. The connection will stay open until one of the parties drops off, then the TCP resources can be unallocated. It's often referred to as a full duplex connection, which is a telecommunications term that defines how a phone line works where both parties can send messages or talk at the same time. Let's see this in action by creating a real-time connection between a Node.js server and a web browser. We'll start in our backend code by building a WebSocket server with Node.js. Using the WS library, we can instantiate a new server on port 8080. Everything is event-based, and the first event we can expect to happen is a connection from the client. When the connection is made, we'll have access to a WebSocket object in the callback. With the initial handshake done, there are two things we might want to do here. We can listen to incoming messages, which would just be text in this case, and then handle them accordingly in the callback. The second thing we might do is send a message back to the client, which we can do with the send method. Now let's take a look at our client-side code in the browser, which has a built-in WebSocket class. It's instantiated with a URL that points to the server, but notice the WS protocol. That will automatically trigger the handshake to open the connection, which we can listen to as an event. Just like on the server, we can use the socket to both listen to and send messages. And we now have a full duplex connection between a front-end JavaScript app and a Node backend. This has been WebSockets in 100 seconds, but if you want to learn more, make sure to stay tuned, because today we're going beyond 100 seconds is that the server cannot broadcast a message out to multiple clients simultaneously. Like, for example, a group chat room where you have multiple users passing messages back and forth. It's definitely possible to build something like that from scratch with WebSockets, but there are libraries, like Socket.io in this case, that can make features like that much easier to implement. You can think of a WebSocket as a low-level building block, where Socket.io is a more practical library that solves common use cases and provides failovers to different protocols when needed. If you're building something real time, there are many different options out there. You might look into Firebase, Apollo GraphQL, or an API like Pusher. Once you bring a database into the equation, real-time features can become very complex, and using a paid service can be well worth the money in my opinion. In any case, let's go ahead and get started with our Socket.io project. At this point, you can open up VS Code to follow along and access the source code on GitHub. What we're going to build here is a bare minimum implementation of a group chat room. When a user opens up the app, they can post a message, and anybody else on that same URL can view the message. And again, one of the big differences from the previous implementation is that the message will be broadcast to all of the connected clients. As you can see in our code, we have a directory for server and app. Server is the backend, app is the front end. In the server directory, we'll initialize an npm project by running npm init y. Then we only require one dependency, which is socket.io, and we can install it with npm.
And so when it
Yeah, what's up?
client now creates a comment, we are then going to look for all other users who are listening or watching that live video, and we're going to push over SSE that new comment so that they get it. And so you may be thinking, okay, but once a new comment comes in, how does the comment service know which users to push this to? Do we need to update our database? Do we need to store this state somewhere? And it's a great question, but it's actually really straightforward. And so all we need to do is have an in-memory mapping in this comment service. And so a new SSE connection is established. The first thing that can happen when this connection is established is that we're letting it know, maybe by the headers, which live video we're watching. And so we're saying this SSE connection is associated with video ID 1. And we can store that mapping in memory. So here's an example of what that could look like. So these connections, these are just pointers to the respective connections. And now if a new comment comes in for video ID 1, I'll look in that mapping in memory and say, who all is connected to video 1? Oh, well, I have SSE connection 1, 4, and 7. So let me send it to them. And I can just do a for loop and do something like connection 1 dot send that new comment that came in. And then it's going to show up to the client and then be able to render. So this is how we're going to enable that sub 200 millisecond latency, because a new request is going to come in. Our comment service is then over SSE going to maintain this persistent connection that it can just push over that new comment. You might notice that this doesn't scale very well. What happens when we need to horizontally scale our comment service? And now we have multiple of these, and it might be the case that a new comment comes in and it lands on this server, but the people who are watching this live video are on a completely different server. And so this one doesn't have SSE connections, right? It needs to somehow communicate with this one, the sender. And so that's one of the things that we'll talk about next as we get into scaling. So before we get there, we're going to look back at our internal plans. Just talk about low latency, and now we're going to jump around. We're going to talk about scale. And so let's come back. We had talked about what that issue is. If the comment service horizontally scales, then we don't know which user is connected to which service and which live video they're watching. So we don't know. So let's break this up a little bit. I'm going to move some things around. I'll keep them on the whiteboard so you guys have them later. But the first thing I'm going to do is I'm going to do a little bit of math. And you might have noticed I didn't do math up front. This seems kind of like a faux pas. System design interview, you're supposed to do math up front. I disagree. I find that most candidates do math for the sake of doing math. They do some estimates on scale, some bandwidth. They look at me and they go, so it's like pretty big. And then they go design the same system they were going to design. That's not useful. Math is very important though, but math should inform your decisions. And so my concrete suggestion to you is to do math in your interview at the point where you have a decision that you need to make. And so in this case, the decision that I want to make is scaling here. And so I want to think about my bottlenecks. We said that we were going to have a million, so 1, 2, 3, 1, 2, 3. We said that we were going to have a million active live streams at any given moment. We have like 1,000 viewers, we said, right? And so what I'm trying to figure out is how many SSE connections am I going to have at any given moment? Because an SSE connection is probably going to be my limiting factor here. Boxes, high-powered boxes, they can handle, give or take, like a million SSE connections. And so we'll use that as a rough number. And then our division becomes easy here because we have a million concurrent videos, 1,000 viewers of each. And so that means that we're going to need 1,000 services in order to handle just the number of SSE connections. And so we don't probably need 1,000 services when it comes to writing posts, because the amount of memory that we have here, the network needed to write to the database, we'll scale this out later. It would turn out that that's probably less. And so this is our limiting factor. And so what I'm going to do right away, actually, is I'm going to do the following. I'm going to separate out a separate service. I'm going to call this like the real-time comment service. And what's going to happen is that this service is still going to be responsible for what it was before, this HTTP post request in order to get old comments, post request in order to create comments, and the get request to get old comments. But instead, we're going to create the SSE connections to this guy. So let me model that in a way that looks a little bit easier. There you go. So obviously this is going to be horizontally scaled too. But what I'm trying to get across here is that there are 1,000 of these servers, right? And I separated them so that I can scale them horizontally differently. And so I might only need 100 of these, but 1,000 of these. And that's why I've separated them out, right? So every time an SSE connection gets established, a user started watching a live video, we're going to connect them to one of these real-time comment services. And now you can see the issue, hopefully. A new comment just came in. Our comment service got that comment and saved it to our database. And now it needs to tell every single one of these 1,000, let's say to make this concrete, let's say that new comment for video 1 just came in. And so it needs to tell every one of these comment services, these real-time comment services, that is connected over SSE to somebody who is watching video 1 that it got a new comment. And so somehow
He said he.
Oh wow, okay.
Who's taking him? You think he's taking him? I guess Leo don't have a brother. Oh. Give him a kiss. Damn, baby socks stink.
It was wet. Wow. So must be one of his close neighbors.
Yeah.
Okay. You wanted to.
He's pretty too.
Yeah, his eyes are
Yeah.
dark, like light blue, like piercing blue.
I just want to also see how you're moving.
Yeah, of course.
Leo, we were gonna get you brothers.
Ugh. I'm gonna wash my feet.
Stink.
You stink.
You stink. Meaning it's hard to like Leo, you know? I feel like shouting,
Pretty calm.
but we don't know. It's just sad, but I think they only get
Yeah. Yeah. No. One's enough already. No. Okay.
like need an arrow here. Be a unidirectional arrow. So somehow we need to tell one of these servers. But how do we know which server? That's the big question that comes up. And so there's two ways to handle this. Let me show you the first here. And the first would be that you would introduce a central dispatcher, is maybe the way to think about this. And so you have something for coordination. Zookeeper is a great technology to handle this coordination. And so Zookeeper is going to keep a mapping, a registration of where all of these servers live in the live videos that they're responsible for. Okay? And so then what's going to happen is that when a new client wants to connect over SSE here, it's going to make a request either to our comment service or a real-time comment service, either way. And we're going to go over to Zookeeper and say, hey, a new person needs to connect. They're watching live video 1. Which real-time comment service should I subscribe them to? It's going to give us a host IP address that we should end up connecting them to so that we can establish this SSE connection. And so let me show you here what that might look like. I'll put this over here, maybe even I'll make it a different color. So that's what exists here in Zookeeper. It's this active mapping of all of the different servers and the videos that they're subscribed to, and maybe how many videos they have. And so now the process would be that when a new comment comes in, the comment service, black, the comment service is going to ask Zookeeper, hey, I have a video for live video 123. Which server should I message that to? And it's going to tell you, oh, it's this server. So all good. And then we're going to come down here, we're going to draw near for these guys. We're going to let them know that we have a new message or a new comment that came in, and they can push it over to their friends over SSE, again via that in-memory mapping. And so really quickly, what actually happens here is that we don't ask Zookeeper every time. That's slow. We have a cache. And so in memory on the comment service, we cache this mapping, this JSON blob. So when a new comment service comes up, it asks Zookeeper, the source of truth, hey, what's the registration? What's the mapping? Let me cache that on my server. And then I'm going to subscribe to any updates. So any updates to Zookeeper are going to get pushed now. And my comment service is going to accept that update its cache respectively. But tying this together, comment comes in, comment service says either by looking at its cache or asking Zookeeper directly, new comment for live video 1, which servers have SSE connections to everybody viewing live video 1. It's going to tell me, it might be 1, it might be multiple. I'm then going to make a request to that server with the comment, and then that comment is going to look up in its in-memory mapping which connections it has for that live video, and it's going to push them over SSE. Of course, this is the unidirectional as well. Over SSE to the client, so the client can render that live comment. So that's option 1. That's the central dispatcher approach. There's some downsides to this approach. The first and most obvious one is that we have an extra hop here. Every time that we come in, we need to ask Zookeeper. And so we largely got rid of that hop here, but we didn't on the connection. When a new thing is connected, it needs to ask Zookeeper which that connects to. And so again, the cache is helping us a lot here, but there are some potential downsides there. I'm going to hold my hands up and say, this is hand wavy. Honestly, the cache is fine. But you have an extra component to manage, potentially an extra hop here. More importantly is that there's complexity in handling changes to the real-time comment services.
Oh, you're so beautiful.
They
give you
for some reason.
Beautiful home, good food, lots of love. Some dogs just get abandoned, but we love you. You're the best. Who's the best? You. You're the best. Yes, yes. Yes, yes.
Number of people they're connected to, but that needs to remain consistent.
Yeah, that's not for you. It's chocolate.
And so we've introduced a little bit of a consistency
That's
issue
chocolate.
here that has the potential or capability to get out of sync. And so Zookeeper has a lot of great tooling to make this problem not much of a problem, but these are the potential downsides here. So that's that approach. Let me copy this and show you what the other of the two approaches would be. So alternatively, we don't have Zookeeper. Instead of having a single source of truth that we go ask, like an all-knowing oracle, hey, where should I send this to? Instead, what we can do is we can just broadcast.
Oh, you so cute. Yes.
So think about the comment service just like yelling out into the ether, maybe with a megaphone. It just says, hey, just got a new comment for live video 1. And then all of these real-time comment services have their ears open, their ears to the street, if you will, and they're listening. And if they hear, oh, live video 1, I have live video 1, then they'll take that new comment and they'll do something with it. And if they hear it and they're like, oh, I don't have live video 1, I don't care about that, they won't. Right? And so in this case, we would introduce PubSub, which is perfect for this sort of broadcasting and subscribing. And so the comment service is going to get a new comment. It's going to, those arrows are the wrong way. It's getting annoying. It's going to put that new comment on PubSub probably after committing to the database. First, for durability's sake, commit that new comment to the database. Then broadcast it by PubSub. So put it on PubSub. This is just a channel. Right? It's just like a message bus that we're going to put this on. And then all of these guys, all 3 of them, in production, all up to 1,000 of them or more, are subscribed to this message bus. Right? They're subscribed to this PubSub. They are subscribers. So this is the publisher. These are the subscribers. And so a new video comes in. It's going to yell by a PubSub. New video came in. And then all of these are listening. And only those that hear one for which they know that they have an active user who is connected is going to take it. And then again, run that connection one. Send with that new comment. So that's the PubSub approach. The nice thing here is that you don't have a consistency issue anymore. And because you don't have 2 things that need to know their own state. These real-time comment services are the only thing that need to know their state. And it makes failures in the comment real-time comment service a lot more graceful. You can imagine that one of these goes down, well then those users just lost their FTP connection. No big deal, right? And so they're going to need to reconnect. They're going to reconnect to a different one of these. We probably pulled another one up as well, but they're going to reconnect to a different one of these. The in-memory mapping is going to be updated. And then because we're still going over PubSub, we're just still subscribed, we're listening, and we're going to send it over to them. So these guys know what they need to care about, basically. There's no other thing that needs to be. So between these two options, there is no right or wrong answer. Both of these options are great. I tend to think that this PubSub solution is a little bit simpler. I think actually that FB Live comments in production went with, they don't use Keeper to my knowledge, but went with a single dispatch approach. It's actually for slightly different reasons around scaling and co-location, which we probably won't get into in this video. But both of these approaches are absolutely valid. In an interview, if you're a mid-level candidate, you're probably not going to get into this much detail. If you're a mid-level candidate, you'll say, I'm going to use PubSub to broadcast from the comment service to a real-time comment service, which is connected over SSR WebSocket and you're golden. If you're senior, it would make sense for you to weigh these trade-offs a little bit. And then certainly if you're staff, you should be able to articulate the pros and cons with these, go into details about them. And then even furthermore, as we'll do here in just a moment, talk about how each of these may scale respectively. So now the problem is worth discussing briefly. So probably just be something that is would be that all of our real-time comment services are subscribed to every single new comment right now. And so you can look at this as like drinking through a fire hose. This is a pretty CPU intensive task because every single comment that comes in, they're checking in their mapping, they're determining if it's right for them, if it is they're sending. But there's a lot of wasted resources here because the overwhelming majority, it's not going to be a comment, it is something that they have to do. And so we want a way for them to just listen to what matters to them. And so what we can do is that we can partition our PubSub. And so if you're using like Redis PubSub, you can call topics. If you're using Kafka, it's called channels, but we're all the same thing. They're just partitions of our PubSub. Think about it, just like multiplying these out. There's not a lot of space here. You get the picture. Kind of like a stack of different message buses here. And so what you can end up doing is just separating using something like the hash of the video ID, modulo the number of channels that you want, or topics that you want, so something like that. And that's how you can determine which one of these it should go on. And then each of these real-time comment services don't need to subscribe to every single topic, every single channel. They only need to subscribe to the subset that they have active client connected to them. So you might only subscribe to a couple of these. And this way you're only listening to messages that come in that are your live video ID or something else that's in this hash grouping. So it's not perfect. It's not like it's only your videos. Someone might be tempted, and I hear this in interviews, they're like, I'm going to partition based on having a topic for each live video ID. This just wouldn't work. Certainly wouldn't work in Kafka. I don't know Redis is limit off the top of my head, but it probably wouldn't work as well. There's limits, reasonable, feasible limits to the number of topics or channels that you have. And so that's why you wanted this hash modulo anything. So you can just group them together and go from one big channel to n channels, where that n channels might be 1,000, it might be 1,000,000, whatever is needed for scale. It's something that can always be tweaked.
From the UI, we have web servers. Start. Okay. Oh no. Sorry, what's web servers come before the API gateway. So web server. Then we'll hit API gateway. Importantly, we do need to factor in like obvious things such as hitting the DNS, as well as obviously we'll have like CDN or something here. Oops. Our CDN here. So once it receives the location of our web server, we can then send them over to the actual web server. So let me think about how we're gonna do this and whether we need like a load balancer or something. So assuming we're scaling to millions of users, and at any point in time, they could either be reading some data or posting, like a cute update for you. So in this case, let's think about how we would do this. If we have a million users, do we need a bouncer? Well, you need a way to send them to all these web servers. So I would argue yes. Let's say we have these load balancers here. LB or something like that. Load balancer. Oh, shoot. Load balancer like that. Yo, what's going on, Amar? Yes, sir. Still prepping. Prepping all the time. How you doing, dude? So let's just say CDN hits the load balancer because we need a way to distribute them to the servers. Because we could have like, many companies in one country that are all using our application. So obviously based on the way the load balancer is set up, we can then distribute them across the web servers. And we also might want to consider like multiple gateways. So maybe we'll have like, a couple of these. Since this is a relatively 40-60 split as far as read and writes are concerned, I would say this is pretty decent. Okay, so all right. Yeah, an interview in the morning and forgot about to read the company. Do you know what the company is about? Ah, damn it, that happened to me too, dude. Actually, the company I'm interviewing for, Friday, the recruiter asked me like, hey, so do you know, what our company is known for and, what we're all about? And I said, I briefly browsed over the company. However, I'm not familiar with the products. So that's all I said. That was my excuse. Pretty bad. But he saw my resume and he liked my resume, so he said, "I noticed it's front end heavy. This is going to be a full stack role. So if that's something that you're not really interested in, this probably won't work out." And I said, "Nah, dude, I'm looking for a full stack role. Like I'm trying to learn new stuff. It's the pursuit of knowledge for me, you know?" So, yeah, I don't know if that worked, but obviously I'm having an interview with them, so it did something. Yeah, it was pretty funny. I have to admit. All right. So we do have an update service here. I want to say that we will potentially need a couple of them. Yeah, pretty much, dude. Yeah, that's the reality, huh? So we have multiple update services here, and we will need a way to distribute based off our gateway. So, let's see. Obviously, we'll start with read because I kind of want to go one by one and not get lost in translation or lost in the process. So, as far as a read API is concerned, we do need a way to cache this. One way of caching this would probably be in the web servers themselves. We could totally do that, but I would argue that obviously based on their location and all that goodness, we potentially may just want to utilize a secondary like cache outside of the web servers because we just want our web. Oh my goodness, we just want. Jeez, okay, I didn't realize I could do that. So we just want our web servers to handle like, you know, what do you call it? We just want our web servers to handle the basic things like showing the user the UI. And this is an application web server. Um, so once we get to this read API, we're gonna implement a cache. So we're gonna put the cache here, and basically based on the well, cache is actually going to get pulled from the database. So I would say database sends the information they're looking for in the cache. As far as writing though, well, every time there's a new update, is it necessary to cache, or can we just read from the database? I almost want to say maybe caching here is not necessary, but our database is taking quite a bit of the brunt, I would guess. So maybe instead of just caching, we could just utilize master slave database structure to help us do like really quick reads. I think that would be sufficient. Yo, what's going on, Mohammed? How you doing, man? So I would say, uh, okay, so I would say we'll have multiple of these, and this will be uh, master slave NoSQL database, and let's think about. We're gonna have slave replicas. So let me. These are slave read replicas, and we'll have quite a few of them. So, something like that.
So the master will then write to the slaves like that, and then when a read API needs to reference some information, it will go through the slaves. For our write API, since we are probably, if we're assuming live updates, then we could potentially incorporate something like WebSocket connection or SSE. But we are hitting, just for eventual consistency, I don't think live updates would be necessary. It adds a lot more complexity. If we use WebSockets, then each one of our services would need to basically open up a connection to allow that live update to show up. So I think in this case, this will be sufficient. And I do have, so the load balancer, the master slave setup going on here. Obviously, if we can scale this, we probably should. So something like that. And likewise, the auto-populate service. We don't want this to ever go down because this is another single point of failure. So we'll have a couple of those as well. So we've got no more single points of failures. We have our databases set up, and we have all our services set up. And so I think this would be a sufficient way to build our system. There's definitely ways to improve it. And I suppose, let's see. So that's pretty much the system. The user basically will go through CDN because we're distributing our servers kind of globally at this point, or at least nationwide, bare minimum. At any point in time, we could actually have a bunch of people, managers and employees, both responding and responding to, and maybe like updating the questions or whatnot. I would argue that the weekly updates questions probably does not. Whoa, this is incorrect. Auto populate questions. This is a service as well. Okay. So basically, user connects to CDN. CDN will direct them to the load balancer, which distributes loads across the web servers. Given that we have multiple companies with hundreds of thousands of employees, so then it will direct them to our API gateway. But depending on whether we're reading or writing, we'll actually send them over to the the database that they actually need to use. And in this case, if we're writing, like updating to basically post a response to their update, then we'll go ahead and check to see, if they're an employee or manager feature flag, because wait, is actually this even needed? The update service will provide them. Feature flag would go actually before the right API. That is actually probably what I would do, because we don't want to allow them to have too much leeway. So the feature flag will determine whether or not they can read or write. And then from here, it'll direct them to what they're allowed to do. So we'll go through the right API. Update service will then allow them to either post a response, or they could change the questions. But depending on our feature flag, that's kind of what we show them, right? So maybe feature flag actually comes. Our web servers have a feature flag. It's kind of built in, I would say. Okay. So then here we update the service. We allow them to post the response, which then will make a query to our NoSQL database. In which case it will grab the specific update that they need to post a response to. So if it's empty, that's most likely what they're going to do. But also, since updates will most likely just grab the last update, so I would argue it's probably better to have an array of objects. And so in this case, like at index 1, it's the latest one, and then obviously which each following update, we actually just need to pull from the last update available, and that will allow them to post a response to that. Now, of course, if it's a manager, they went through the feature flag, they have that option, they're allowed to write. They'll go through our update service, which will direct them to the change question service, which then will allow them to auto-populate, so if they so choose. And then obviously they can change the questions of the questionnaire, so they'll make a query to the database. They'll be allowed to update the question based on the latest available updates, and then that will be sent back to the read replicas, which can be referenced again through the read API. We'll handle all the UI related issues here in the front end. So when posting a question, we want to showcase the question has actually been posted on the user interface side of things. Even if there's a minor delay, obviously, let's say it's like 500 milliseconds before the update actually can be reread, or before the post actually gets posted or updated inside the responses, then the web server will still show that update first anyway, and then we can, upon refresh, actually, it will be ready to display the updated data. So that makes sense to me. What are some questions they would ask me? I need someone who's done system design interviews to like question my design and give me a hard time of how I can fix this. Because this looks pretty bare bones for some reason. All right, that's pretty much it. I think we'll just watch one more video.
Our next stop is core entities. Remember,
These are the nouns we'll use in the design. Depending on the problem, there can be more or less discussion here. For a newsfeed, our entities are pretty simple. We have a user, we have a post, and there's a follow relationship. Fundamentally, newsfeeds are about finding the posts from users you follow. We don't need to build out a full-blown data model here, so I'm going to avoid attaching properties or attributes to these entities. We'll get to that as we start to fill out our high-level design. And that's it for our entities. Now let's move on to our API design. The easiest way for us to build out our APIs is to refer back to our functional requirements and make sure we have coverage of them. It's not always the case that your API is one-to-one with your requirements. That's totally okay. But we do need to ensure that our APIs satisfy our requirements. Once we're done, we'll know that our high-level design is complete when it implements all of our APIs. For this problem, we'll need 3 APIs. First, we need a way to create a post. Let's keep this simple with a RESTful post endpoint. So we'll post to /posts, and like pass along the content of the post. Let's assume that we'll return a 201 when it's successful, and maybe we'll pass back the post ID. Great. Our requirements don't have anything more here, so we can move on. For our next API, we need a way for users to follow each other. We don't have an explicit requirement for unfollow, although that makes for a sensible extension that some interviewers might ask. Let's use REST conventions to create a follower edge by putting to the user's followers. So put /users ID followers. We don't necessarily need a body here just because there's really no metadata that's associated with this. Finally, we need a way for users to access their feeds. Moreover, we need a way for them to gradually paginate through their feeds. For this, let's create a get endpoint for a virtual resource feed that has both a page size and a cursor. So we'll get /feed, pass in a page size, which might be 25, and a cursor. And this will return a set of posts and a next cursor. Cursors are a very common approach to pagination. In this case, our cursor could be a start at timestamp, which tells us how deep into the feed the user is traveling. When a user loads a feed, they'll be able to view a set of items from the present time to some point X in the past, which is the time of the last item in that response. When they request their feed again, they'll pass in that time and retrieve the next set of N items, all which are older than that timestamp. This way, we can ensure that the user is able to see every item that's been published, even as they query deeper into their feed. With that, we have our 3 APIs that satisfy all of our functional requirements. Sometimes people will ask, do I need to use REST here? And the answer is not necessarily. If you controlled all the clients, you could use gRPC, for instance. You could even write these endpoints as function signatures versus REST endpoints. But if you haven't been doing it that way for a while, I'd recommend instead you just learn REST, as it's very standard across the industry, and you'll likely avoid any yellow flags for REST zealot interviewers. No reason to go non-standard if you don't need to. So that's our API. The next step is our high-level design. Here's where we're going to try to implement a system which minimally satisfies our requirements. While it's not strictly necessary, we recommend to try to build out the most basic system that satisfies the requirements before you start to optimize. The reason for this is simple. Candidates often lose themselves in micro optimizations that aren't actually important before they get a working system on the whiteboard. This can be a major problem, especially if you run out of time. So let's get a working system, and then we can take a step back and figure out where to optimize. Our first requirement is to enable users to create posts. This is pretty simple. We need a service which is going to accept our post requests and store them in a database. For each post, we need to keep track of who created it, its content, and when it was posted. In this problem, I'm going to use DynamoDB as the backing store, but you're free to substitute in Cassandra or any other scalable wide column store. We'll put our post service behind an API gateway and load balancer. We aren't getting into the details just yet, but as posting volume increases, we can scale in more post services to handle the incoming requests. Provided we don't blow up DynamoDB, this is actually pretty scalable. So great, our first requirement is out of the way. Next, we need to allow users to follow each other. Some candidates look at this and immediately assume we need a graph database, but this isn't the case for this problem. Graph databases like Neo4j are really useful when you need to do comprehensions, like find all the users who are followed by at least 2 men who also follow each other. These can be tricky queries to answer or execute, and often require specialized query languages like Cypher to even ask. But in this problem, we only need to answer queries like, tell me all the users who are following this user. So we're going to keep things simple. As a quick aside, in interviews, I highly recommend you start with simple approaches that are tightly fit to your specific needs versus adding a ton of complexity earlier on. There's plenty of time in the interview to layer on new complexity as you need it, But if you tie yourself in a knot early on, you're going to have a hard time getting untangled in time. The simplicity of a solution is a hallmark differentiator for junior candidates versus more senior ones. Here, we're going to follow the same model we did for post creation. We'll have a follow service, which accepts requests from our clients and writes to a follow table. In the follow table, we need to support two obvious types of queries. First, tell me all of the users followed by A, and then tell me all of the users who A is following. The way we're going to do this is putting a partition key on user following and a sort key on user followed. This will allow us to list for a given user all the users that they are following. To support the reverse, we can create what's known as a global secondary index, or GSI. In Cassandra world, this is just a secondary index. You can think of the global secondary index like another table, but one that's managed internally and consistently by DynamoDB. On our GSI, we can choose a different partition and sort key. And for this, we'll choose the reverse. Our partition key will be user followed, and our sort key will be user following. When we want to query all the users who are following a given user, we can query this GSI, add a particular partition key, and pull out all of the users who are following a given user. For the record, DynamoDB puts a limit on these range requests. You can return no more than 1 megabyte of data. You can then page into the results. Since our user ID and metadata are on the order of 10 bytes, we can retrieve a bit less than 100,000 entries per request. This will be a problem for our most followed accounts, but a non-issue for everyone else. Great, we're almost there. Let's talk about the feed next. Our third requirement is to be able to view a chronological feed for a user. We'll create a new service for this because unlike the post and follow services, this is a read-heavy service, which will bear the full brunt of our traffic. We'd expect far more people to pull feeds than to create posts, for instance. Also, generating the feed may be computationally heavy, depending upon how many posts need to be merged together. The feed service can interact directly with the post and follow tables to satisfy the requests. A microservice fan will tell me I need to wrap these tables behind APIs so that these services aren't querying the same data, but that's a huge waste here. The decoupling benefits are dwarfed by the overhead we introduce. But if you feel like your interviewer is going to be a stickler for microservice best practices, go for it. In the ideal state, the feed service will take in a user ID and query the follow table for all the users they're following. Then we'll take that list of users and query the post table for each one of them to grab all the recent posts for that user. Finally, we'll merge all of these lists together before returning them to the requester as feed. If this sounds problematic, it is. There's a few big problems here, but let's address the most costly ones first. When we want to query our post table, we need to be able to look up the posts created by a specific user. We can't do that currently with our primary key being the ID of the post, which is useful for pulling a specific post, but not much else. So we'll again create a GSI, sorted by creation time, to do that. Cool. We're halfway there, but alarm bells should still be ringing for you. What about if the user is following a ton of other users? What if the creators have a ton of posts? At this stage in the interview, we're going to acknowledge there are still problems verbally to our interviewer and commit to solving them in a few minutes when we get into the deep dive. We want to keep traction so that we can solve our core functional requirements before we enter our optimization loop. Our final requirement is to support pagination so we can have a clean, infinite scroll experience for end users. To do this, we need a way of grabbing pages of the user's feed. Remember how earlier we added a cursor argument to our API design? That cursor indicated the oldest timestamp the user had seen in their feed. We can use that timestamp as a filter as we go retrieve posts. So when we query the post GSI for each user the requester is following, we're going to retrieve no more than the page size number of elements, and we're going to query with a created at that is less than the cursor. Basically, we're going to grab the most recent post before this date. That allows us to page back infinitely. And that concludes our high-level design. We have a system which satisfies our functional requirements and will work with a lot of users, but not for users who follow or are followed by a lot of people. We'll start our deep dives by addressing the problem head-on. How can we deal with accounts that follow a lot of people? In our current design, if you were following 10,000 people, then our feed service needs to make 10,000 requests to the post GSI, returning maybe 10 million aggregate posts, all of which need to be merged.
Coder pad. Oh wow. Okay. Cool. I did not realize this was a thing. So let's actually TypeScript is pre-configured to support TypeScript. You can use so it starts with TypeScript. That's pretty cool. So let's actually probably remove this. Just type in LOL for now. Let me set a timer for 30 minutes. Okay. So in here, let's go ahead and start by our components. We do also want to include our store. And maybe in here, I'll create the use fetch.ts. In here, we have export, or actually const use fetch is equal to this export use fetch. First things first, I do want to store the error to state, and it will eventually start with null. But we can specify the type as well. It's either going to be and then for the next portion, we have data, set data. This will also be a use state, which initially is null. And then we have loading, set loading, which is always going to be true. We will be returning all of that information. Okay. Now this is where I want to do the asynchronous process. I will be using a self-invoking function to get this done, just because I think it's a cleaner way of approaching this particular issue. So we will be using use effect, and we'll only run it once as needed. So here is our self-invoking function. So start by calling this asynchronous. We will need a try catch. Wow. And then of course now we can consider things like handling the response, which is fetch random person. So this is our API. Let me go and grab that. And just for the sake of doing this, we'll have const equal to this, that. Right. Whoa, whoa, whoa. Okay. There's my coder pad. Okay. So here in use fetch, I will call fetch with some URL. So let's go ahead and pass that in. URL will be of type string. So we'll fetch that,
If the response is okay, we'll do some work. Otherwise we just set error to response dot status text like so. Of course, in this case, we just set error to error. Right. So if the response is good, what we want to do forgot to add dependency is basically say, okay, so response is good. Let's go ahead and grab that JSON. So that response.json is what we're getting back. And let's just console log that first to see what we get. So let's go back here. Const error data loading is equal to use fetch. And we will pass in base URL. And we are getting the promise is pending. All right, cool. Promise is pending. It's because I did not await. There we go. So now we get results and info. Looks like results has an object here, so that's good. All right, so in that case, I do want to actually destructure this so it's easier to reference data dot results like that. And then we're gonna set data to the item itself. Okay. Let's refresh. Should be good, I think. We're not logging anything yet, are we? Okay. Well, we go back here. We have error, this URL. Let's go ahead and start by if data console.log data. There you go. There it is. Cool. So in this case, I do want to say if there is data, we'll render our function here, or RJSX. And of course, if error, we will return the div, and we'll just say error for now. Of course, if we have loading, we'll just say loading. I realize now that actually the problem is at the end here. We should set loading to false. There we go. All right. So this is what we have so far. So now we can actually start generating our components. So let's start with navigation TSX. We also want, actually, let me delete this and go with navigation. We do have, start with navigation. So here is index.tsx, include nav bar. Sorry, let me see. Let's rename this to nav bar tsx. We'll create the nav links.tsx, and we'll go with the nav profile. Right. I will create also a constants folder here, and actually in here I'll create for now I can't think of anything specific. I mean, I guess what we can actually do is rename this to URLs, and for the app here, instead of putting it here, let's place it in our URLs, and then we'll export base URL. All right. Cool. So here we need to actually import that. So let's do that. We should be good. Right. Then in our navbar. Oh, what? Oh, they don't have that function. Okay, so we have a function navbar. And in here, we're going to return like a div. And in here, we'll just do nav. No. We will actually, so this is going to be the parent. We need to take in quite a few things here. Create a links.ts. Points links is an array. We have overview. Ones, updates, and feedback. Then we can export links. So here in navbar, we will be taking in links, which I guess we can handle here. Oh, if they actually make me do some routing, that will be interesting. So if they make me do routing, I mean, pretty simple, but can I include routing? Okay, I have no idea. All right, so let's just import links in here. So we'll start by navbar. Links is equal to links. And let's go into navbar. So we will be taking in links. We will also be taking in, actually, do we need links in here? We can probably make it even cleaner by not putting the links here and actually just referencing the links here. So let's do nav links and let's just turn div, and here we will just do links.map for each link. And I know that using index for keys not recommended, and we could go with something a little bit more unique. I'm sorry, it should be a button. So we can go with something maybe like what's going on here? Consider adding import. Okay, then we can just render the link, stuff like that. Why is it saying? React refers to UMD global. React refers to a UMD global, but the current file is a module. Adding, oh, what? Export the file. Turning JSX, why don't you
getting the same thing here. React refers to import. What does this mean? React refers to a UMD global, but the current file is a module. Consider adding an import instead. Is that a curly brace? No, it's supposed to be this. Oh, you're not returning the button. And this nav links, yeah, I am returning the button. Oh, I see what's going on here. So I know what this is, but it's still throwing the same error. And if I go to my nav bar, it looks like it's still throwing an error for this. I don't know why it's doing that. It's really odd to me. Nav bar, poor nav bar. Oh, okay, that's really weird. It's still working. Okay, it's still working, but it's throwing an error. Don't know what this means. What is the quick fix? Import React from React? Seriously? Dude, my IDE does this for me, man. I tried doing that earlier. I didn't realize that React is it's a default export. So I tried doing this and it didn't work. So that was my bad. Okay, but yeah, anyway, so here's the nav. Here are the nav links. We've imported links from the constants, so it will return this. And in my nav bar, I'll go ahead and render this nav links and we'll import it. And then here in my nav profile, yeah, dude, that's crazy, right? Yeah, the freaking, it's weird because we're using a different environment, so it's okay. All right, anyways, so function nav profile. We'll export default nav profile, and here we'll return. Yeah, I know, it's crazy. Yeah, it's wild. I guess JSX is actually React. So once you start including JSX, it becomes a required import. Even though in the when you configure the tsconfig files and stuff like that, you can bypass it and make it a default import at all times for everything TSX. Anyways, I don't want to do that anyway. So for the nav profile, we will be receiving a couple things. We want their profile picture, we want their name, and we want their email. So let's do that first. Name, picture, and do picture, name, email, like that. And in here, let's actually start to pass the data through. So what we could do here is actually take the data and pass it into navbar. Of course, we could use context here, but I don't think we're actually going to write anything up to the state or change the state, so that probably isn't needed. That's my thought process right now. So for picture, we have it's data.picture.thumbnail. So we do data.picture.thumbnail. And then for name, we actually are going to use data.name. And I remember this, it was dot first. And then we'll space that out, data.name.last. And the last one here is email, so that will be data.email. Okay, thank you for not auto formatting. Now I kind of like CodePen a little bit more. So there you go. That is what that looks like. Let's go into our nav bar and picture, name, email, and we'll pass to nav profile, and that comes before links. So actually the same deal we had here. I'm gonna copy that. Whoa, copy that. Go to my nav profile. Whoops, I mean my nav bar, and paste it in. That is absolutely fantastic. I love the auto formatting they have. Oh, my bad. And that will just be picture. And this is name. That's email. And we did not import profile, so let's do that. Okay, we have the buttons. But the profile itself seems to have no content. Okay. Don't forget to add a key prop to the links. Oh yeah. Yes, good catch, good catch. I literally said that earlier and I totally forgot. Okay, so we have the key prop now. So we shouldn't be getting, well, apparently the sandbox doesn't throw that error, so. All right, we're at the nav profile. We're basically gonna have an image. We're gonna have a span. And we're gonna have two of them. So the image source is going to be picture. For our span, actually, we're just going to include our name as well as our email, and that should be good. It's rendering fantastic, beautiful. I love it. So now we do the CSS. Can I really not just add stuff? Front-end frameworks. Oh, wow. Okay. Never mind. Let's just go back to what we were doing. Okay. Since we're using app.css here, I will remove, or I'll keep this, but I'm just gonna close it so I don't have to look at it. I do want to change a couple things here. First off being, we will create a nav wrapper. Oh, let's start with nav wrapper. We'll display flex. Padding is going to be, we'll say like 10 pixel by 10 pixel, and of course, shame on me for not using semicolons. And let me just apply that wrapper so I can style this. So this will be, there we go. Class name is nav wrapper. There we go. So we're getting somewhere. Looks better. All right. So we have padding. I do want to let's see, round it off. Maybe border radius is like 20 pixels all the way around. Border radius 20 pixels. Hello? It's not working. Anyways, we'll justify content center. Oh, sorry, justify content space between. We'll say the width is, we'll take up only like 60%. I think that's pretty generous. But it's also not working here. I do not know why. Space between. It is working, but it's also not working. Let's see. All right, well, let's just start with this, right? Align items, center. Cool.
Let's go over to creating our .nav profile. And in here, we will display flex as well. We'll have a gap here. The gap will be, I'll just say like 8 pixels is generous, which is what I did before. Same deal here, I think. We want to justify content center and align items center. Let me now go over to the nav profile and class name is there. Okay, cool. So now I believe they need to have their own divs if I want to make it look pretty. Hold on, let me grab this. Put you in there, put you in there, and put you in there. It's not, which is interesting. How did I do this last time? Trying to think here. Do we really want it to be? What if I did column instead of row? Because normally in my mind I think, well, this is going to be a row, and inside we're going to have 2 columns. So what if I said flex direction column? And inside the nav profile, I undo that, and then I do that. I want 2 columns in the rows. Yeah, this is probably not the right way to do it. Keep it as a row, nav profile, and then I forgot how I did this. Last time I did this, I was able to like magically generate a column for this without actually specifying a column, which is pretty nuts, I think. Unless I did it in the CSS and I just didn't realize. So here I could do whoops. Here I could do like dot nav profile, and then we'll do section. Oh, sorry, no, span display call. Oh, whoops, this is display flex. Flex direction is column. There you go. Okay, I did do that last time, I think. I probably did that. Yeah, because I don't know how else you're gonna do it. To be fair. Okay, so that's done. Obviously with the way this is set up, like that's pretty nasty. So we do only have 3 minutes left, dude. This is all I could do in 3 minutes. That's crazy. This is all I can do in 30 minutes. Oh my god. I mean, I guess I could maybe optimize this by setting some more CSS. I mean, this is all I can do in 30 minutes. So like I have 2 minutes left, so maybe I can do like snap profile, nav wrapper. We'll say max width is like, we'll calculate 100 view width minus like 50%. Does that even work? Dude, I don't even remember. Oh, sorry, what am I doing? 80%. This worked last time. I don't know why it still shows background is FFF. Like it's, oh, and then self-center. Align self-center. Boom, there we go.
Plus, I also need to consider the min height is 100%. What? Why is my app.css 100 view height? There we go. Oh my god, bro. Sweet. Justify content space between. That's my nav wrapper. Align item center. Align self. Start actually. Oh shit. Isa. Flex direction. Big column. No. Okay, so actually only 1 minute left. I think in here class name is app. So in app, I say flex direction is a column. Justify content center. I don't want that. There you go. And then we want just like padding all around, right? So we'll do something like padding 25 pixel, 25 pixel, because usually designers like that. And boom, so much better. Of course, the background will probably be this darker thing here, and then this can be FFF. Oh snap! Okay, there we go. Yeah, so I'm pretty much out of time. I only have 15 seconds left. I don't know what else I could do. So yeah, I mean, I think this is pretty much what they'll expect. You click on like updates, obviously looking at folder structure, stuff like that. So, yeah, so you said earlier P is a block element, span is inline, correct? And maybe I can try that. So let's actually go into navigation profile. I'll use P or something. Oh, it does not update. Oh, sad. Okay. So we'll do something like that. Oh no. And then, well, yeah, I mean, this looks a little bit better. P creates this crazy gap in between, and I think the reason is it like margin? Yeah, dude, it just adds margin. So like if I were to do with a paragraph, I would need to, it's probably not necessary to use this because paragraph really means a paragraph. Even though it says no margin, it is adding some intense, like it's definitely adding margin. Like there's no way. I mean, I could do here in the CSS, right? We can copy that. And we'll specify the P element and we'll say like margin 0, and that fixes it. Yeah. Yeah, so yeah, you could definitely use P. I would say you would have to fix the extra margins it's adding, so that would be the only issue. But aside from that, it looks pretty decent. There's gapping missing here. I don't know what else I can do in 30 minutes, man. Is this decent for like mid-level, bro? This ID, this place to develop on this is a lot cooler because you get like folders, you can add stuff. CodePen's a little bit more eh. Um, what else am I missing here? Oh, I can't even arrow key over the files. Kind of sad. I have a store here. Obviously, if we were to use Redux, which is not even needed for this, to be fair, we don't even need to use context API at all because I mean we're only passing it down 2 levels, right? So like 1 to hit navbar and then 1 to hit profile. So kind of not really needed. I feel like it's a little bit unnecessary. Yeah, I mean, I think this is okay. I think that's it. I don't know what else I could possibly do in 30 minutes. I'm trying to think what I could do in 30 minutes. 30 minutes. I think they just really want you to just to see that you know how to like handle promises. That's it. 30 minutes is really not a lot of time. If it was like an hour, I would assume they want me to add like Redux and you know, like some kind of state, like add like a proper state management, um, and like get a little bit more crazy with the CSS. Right, right, yeah. So hopefully this is good enough, man. I am honestly though, dude, fucking petrified at my system design portion of things. Where did I delete it? Where's my Excalidraw? This is where's my Excalidraw? Let's go to Excalidraw. Oh, it's right here. Oh, dang, dude, this is not what I drew earlier. That's crazy. Can I delete this? Excal or I'll just pull it up in my history. What am I doing? Code sandbox, WebSockets, system design. Wow, it's so far back. Let me just search Excalidraw. All right, let's open this one up. Oh, this is the only one it saved? There's no way. It must be on Brave. There you go. All right, so I'm in a great spot. Oh, you're being too positive, bro. You're being too positive, man. Have I been to any system design interviews? How long do they go for and how deep did they test my knowledge? I've only done a front end system design interview, so I can kind of detail out how it goes because basically they wanted me to model a system that handles curbside pickup. So based off the front end only, right? This is a front end, um, like React slash JavaScript based system design. You we without Excalidraw, but nowadays you probably use Excalidraw, right? You probably start by saying like, well, I this is how I would do it now after studying system design. Let's just grab something that I can use. So let's start with these two. All right. So let's say we're designing like curbside pickup, and this is not necessary. I'm just doing this so you can kind of read it, hopefully read it. Okay. So this would be like design a curbside pickup system. Um, so the one I have coming up is 30 minutes. The last time I had a system design interview, I think it was also 30 minutes. It didn't go that long, or was it an hour? No way it's an hour. I think it was, or was it an hour? What did he do? What did he make me do? It was, oh yeah, it might have been an hour. I think it was partially behavioral and then like some system design. So I would say like 30 minutes system design. So design a curbside pickup system for a grocery store, right? I would start by explaining kind of what we're dealing with here. Um, Obviously we want to start with maybe like the core. I like this. I like starting with core entities. You obviously will have like a guest or a customer rather. Um, you will have like a shopping cart, right? So we can call that just a cart. You'll have a checkout and probably like obviously payment, right? So and just because this is bothering me, payment should come before checkout. Okay, so this is probably where you want to start, right? These are your core entities. Let me actually, hello. Okay, so these are your core entities. Next we want to focus on what our components will be because this is front end. But I can also do like practice on the system architecture side of things, but we'll start with I guess just this. So this will contain a few things. Jesus, dude. Hello? This is bugging me out. Oh shit. Okay, so it's kind of annoying me. All right, so we'll start with components. Obviously for the front end, we would be looking at so normally for an architecture system design interview, you would actually go through by modeling functional and non-functional requirements. So let's actually do that, right? And we'll start with functional requirements. And first things first, customer makes, see, I just realized aside from just the checkout, we also have parking location. That is important. We cannot forget about that. Okay, so for functional requirements, we obviously know that the customer can make add items to cart. We can then what else can we do here? We can also view cart. Let's say, and the thing is too, with system design interviews, usually you can ask them clarifying questions like, what is I'm gonna list out all the functional all the requirements that I think that are functional. Do you think that there's anything outside of this that maybe we can consider out of scope? Maybe something that's in this list that can be considered non-functional, right? So add items to cart, view cart, obviously make payment, and we also need to consider things like time till pickup ready, make payment. This is part of checkout, right? This is checkout. Core entities is just customer, cart. Is that it? Am I fucking up? Parking location, checkout, and payment. Customer and cart. So these are actually, I think this is actually all we have. Parking location, customer, cart. Obviously the store itself. Sorry, I'm like going back and forth. The store itself, the customer, the cart, and the parking location. Okay, so here we're at functional requirements. Add items to cart, view cart, make payment, time till pickup ready, locate, or like designate parking, designated parking, and what else am I missing? Add items to cart, view cart, make payment, time till pickup ready, designated parking. We can add / remove items from cart actually. This is actually kind of pretty dense and probably too much for a 30-minute interview. So they might actually say, or they might just tell you to continue, to be fair. Okay, and then obviously we can actually say add remove items cart, view cart, make payment. And maybe they might say like time to pick up ready. No, that's important though. So I'm going back and forth. Okay, we'll just start with this. We can say that there are some bonuses that we want to consider. So there's some bonus things such as we could potentially I don't know. This is too much for me to think about. I think we'll just start with this. Probably ask the interviewer like, hey, is there anything in here we can consider non-functional? They'll probably say everything is functional. Cool. All right. If that's the case, then we can go ahead and move over to the non-functional aspect of things. So this will be non-functional. For the non-functional side, it will essentially be like, we'll start with like scale to, well, this is just UI side, right? So if I'm gonna incorporate, well, we can still incorporate this, and then we'll move into the architecture implementation. But let's say we have one store and we want to scale it up to, I'm going to set a timer now, I guess. Usually they'll tell you what's not functional, but scale to handle like millions of customers to millions of customers. Obviously we can say that each transactions are not equally distributed. Likewise, same goes for parking actually. So we can say parking allocation not equally distributed as well. We do, however, want the time till pickup to be as accurate as possible. There is consistency, but I would argue between the employee packing everything and bringing it out to the user, there's actually quite a bit of generous time. Usually customers aren't like that impatient. Also, we can factor in like the customer needs to drive there, park their car, find parking. Actually, no, it's designated parking, so that's not a problem. So time till pickup actually can be eventually consistent. That's perfectly fine. What else are we missing here? I think that is, oh yeah, so obviously adding items to cart needs to be pretty quick. We don't want to have them add to cart and then when they go to checkout, it's missing an item, right? So adding to cart must be fast. And obviously for the store employee themselves, what are we missing here? Parking allocation is not equally distributed. We can consider that they need to get notified of what the cart order is. So notifying employee of checkout or order must be fast. Okay, so this is kind of what I have outlined here. This is what I'm thinking. So these are our functional. We'll do the main design based off this through React components, and then we will build on top of that for the architecture side of things. I think that's the plan right now. So, whoops. Let's do that like right there. Okay. So if I'm gonna design the components, we do want to go and touch base on, let's say, like the APIs, right? So as far as the API is concerned, we will have probably something pretty simple. We need to handle add, remove items from cart. So this is one thing we need to worry about. Add and remove items from cart. All right. So for this one, it's always going to be a post for sure. We're looking at, hello, can you, I'm battling the UI. Okay. So we're gonna post items to cart. This will probably go through maybe some cart endpoint, and this will be cart ID. And then we can specify, this will be either a add slash remove, and it will include the product ID as well as the quantity, right? So we'll go ahead and include quantity like that. In this case, we do need to specify the body for this. So we'll just say like the cart item and the quantity, as well as the users. Cart item, cart ID, and the quantity. Are there any remote internships in web? Probably. I'm not sure, dude, honestly. I actually never did an internship myself, so I kind of not very reliable person to ask for that. I'm sorry. Okay, so here's our dude, look, it's a waterfall. Okay, so here's our post. We handled the add and remove cart items. We have now a view cart, so this will be view cart items. This will be a get request from cart, and we'll need the. So I'm gonna assume here that sure we have the user ID and that's important, but if the user's already logged in, then we don't really need to care about the user ID. We just need to make sure that we have their cart ID. And in fact, depending on the user, they probably already have a cart ID located somewhere, and so we just need to specify cart ID here, which will be more than sufficient. And that's it. Yeah, that's pretty much it. We don't need a body for this, or a request body, so that's fine. So we did that. We do have a make payment, and we're gonna assume here we're using nothing except or maybe our own system. Actually, the most likely say making payment is probably too crazy, and that'll be considered like a bonus. So we'll skip, we'll say make payment is a bonus. So let's say this make payment. This is going to be considered bonus. So we'll skip this because I think it gets a little bit complex once you start doing make payments. For time till pickup ready, or it's pickup notification. It's better, huh? Yeah, I would probably rename this to pickup notification. So this would be pickup notification. This is going to be put post patch delete. It's gonna be a patch, and it's kind of like its own service. But we'll take care of that later. I want to say this is a patch. And this is internal, so I don't. This will be pickup, and this will be. Each order will probably have an order ID as well, right? So this will be order ID. I think that's it. And the body for this will be just a countdown timer, so just be like a timer of some kind. What else am I missing here? Designated parking. Designated parking is it's gonna be a get. Yeah, so this will be designated parking, and this will be a get. This will be um, oh, pickup order slash order ID slash pickup. And this will be order slash parking. And then there is also a service that's going to handle this. There's no body request for this either. Because the service is gonna basically dictate where the parking goes, and we're just gonna send that back to the user. So I have everything set up, API set up. We can start drafting the core components here. So let's say we had the mobile view, kind of what the user is looking at. First off, let's say there's like a notification that pops off. Or let's say there's like a cart maybe. So let's go ahead and start by saying that there is this navigation bar here. And inside this nav bar, this is where the where is this? This is where the cart sits. We will have a separate notification icon here to let them know of, I guess, the timer. So this will be like timer, and let me make that a little bit more to size. Okay, so they have a little timer here. Of course, if you know they don't submit a order, the timer itself doesn't show up, so that's perfectly fine. And let's say they're viewing items in their order list, right? Or are they already in the cart? That's what I'm trying to think. They're adding items to their cart. So let's just say that this is just like a list, a laundry list of items. So we can, you know, put an item here, here, and so on and so forth. Right, so these are all just items. Okay, and then okay, so these are all items. Inside each item, we can specify particularly if they want to add maybe a like add to, why is it not working? Jesus Christ. So we can do like add to cart, something like that. So there's an add to cart button. There is like, of course, like product details. And then of course there's the there's like another checkbox here. They can specify quantity, QTY, and we can say that there's like potentially a plus here and a minus here. So let's do that, plus and minus. All right, so that's pretty much the general layout of kind of what they're seeing on the page before they actually get into the cart. So this is just like the adding items, like the products list page. And then let's create the cart page. So, whoops, cart page. So if they're in the cart, we can still show this. Actually, on the products list page, this should show quantity, to be fair. And we're not quite yet at the timer. We'll probably need a separate page to handle showing like where the parking location's at, you know, which store they want to go to, plus you know the time left available or time till their order is ready to be picked up. So if they're in the cart page, obviously what we need to do here is there's product details. Instead of a plus or minus button, we do have the quantity. Instead of add to cart, this will be the price. And so that's the price. What else am I missing here? Like yeah, pretty much like design wireframe and then like kind of go through the API. I would also say like when designing the API, there is probably going to be questions about like what was the example that I dealt with? I remember when creating a React component, I don't know, they might ask you. I remember the questions mostly pertain to like how are they going to receive notifications, go through the components, explain how things work. They want to understand the flow, right? So like you go from product page to cart page, and then from here, you know, they can go to the parking information page, stuff like that. So put that here. So this would be like parking location, and then you would list that stuff here. So I think generally speaking, that's probably what it would consist of. They might ask you questions like, if you were to use a specific, you could probably dive into like what libraries you would use, um, like how are you going to handle like forms and stuff like that. In this case, if we do have checkout, right? Because well, I said make payment or checkout as bonus, but let's say they did ask you like how are you going to handle a checkout. So like if you did have a checkout page like over here, you know, um, how are you going to handle like forms? You could say like, well, we could use potentially like Redux to handle like all the form state managements, but there are alternatives like Zod, and maybe you could explain why you would use Zod over Redux. And for me, basically, the simple explanation is, well, Zod kind of has built-in features where you can utilize their like error messages, and it's just an easier way of handling it. The downside being now you do have to add an additional library, which increases bundle size. So those are all things you want to consider, and you know, obviously in this case, well, like instead of, so we have a couple things, right? We have Zod to handle form management. How are we going to handle checkout? Well, in most cases, we could probably do our own form of credit card validation, but that's very, very risky. It adds a lot of overhead for the company and a lot of risk, which I mentioned earlier, right? So instead of using Zod or Redux to handle any form management, we actually can probably use like obviously the Stripe API, so you can like go into detail like APIs you would end up using that you discussed here, right? So like let's say they add to cart. When they add to cart, it will call the API, and then you can specify like, oh, this API service, like what does it do? What are the logics? So like if we're gonna add something to cart, there's probably error state handlings you want to talk about. And this is like strictly front end stuff, right? So, given that this is the general use case, 30 minutes, don't even know how far you can possibly get into this, but um, that's probably the most I would get into. Um, Obviously, like you can go into more detail, right? So, like, let's say the employee doesn't look at the same thing the customer is using. So, this entire thing here, this is actually strictly for the customer. So, like, this entire piece here, this is for customer view, and this is the customer application. I guess that's better way of putting it. You would actually have an entirely different setup for the employee because the employee themselves will have to acquire the notification, and they probably have a different system going on, right? Like they might not use mobile, so you might want to consider like, hey, this is going to be mobile first design or something. And then whoa, and then when we go here, like well, they might have like a tablet or something too. So yeah, yeah, of course, of course. So then you would specify like, oh, this is the employee application, and maybe like dive into details about how they would go about this. I think the goal though in 30 minutes is to complete the design. So something more generic. Don't get too crazy with making things pretty, but I like making things pretty. I know that's terrible, but it's kind of like part of the process. If we were, however, to move into an architectural system design, and I'll reset the timer and try to hit this in 30 minutes, we're going to start with a really basic high level overview of what this should look like. So, um, having done this already, we start with the client, and the client will make a request to our web server, which I have right here. So, this is our web server. When the client makes a request to our web server, the web server does need to dictate and communicate with our API gateway, simply because there is no. Let's see. All right, so I do want to also take into consideration this app is going to be way more read heavy than it is going to be write heavy. Oh yeah, on YouTube. Oh dude, I don't know. I don't know if that's. I've mentored people in real life, but it's definitely different, right? It's a little bit different. But yeah, okay. So let's say client makes a they submit their order, and we're not dealing with orders. We're just dealing with the actual like notification, plus we're dealing with submitting that parking information to the user and the user being able to read that. So in this case, excluding our bonus case here, which is to handle the checkout, um, we're strictly just dealing with a very, very heavy read, a very heavy read application. So that being the case, will the users ever need to write anything? I'm trying to think. We do have a post, and that is to add or remove items from cart, but this is strictly. I mean, okay, we can do that. We can do that. Okay, so we'll do. This is a write API, and then we'll just do a read. This is a read API. So given that we have both of these, let's start thinking about how we can approach this. So this is going to be a gateway. This is our API gateway. If the user decides to update their cart, we do want to handle that. And essentially how this works is the user will send the request. API gateway will say, okay, we need to update our database. So let's create, I don't like this, dude. Let me create my own database. And we're gonna say the background is black. Black as fuck. Hello? 000. Hello? Why is 000 is not black? Dude, that's crazy. What? Do that. Okay, perfect. And then this will be db. Let me save this so I don't forget. Okay, so let's say this is our database. Very simply, they will update the database based off of the items they have in cart or what they wanted to change. Reading is pretty much the same deal here too. The web server communicates with the API gateway. Gateway says, hey, I want to pull some data from the database, and we can read directly from the database. However, we have a couple services we need to design here, right? One is to add and remove items from cart. And this will be our backend service to handle this. We do need a backend service to send the notification back to the user. And we also need a service to designate parking because we're doing a microservice architecture here. Separation of concerns is super nice. It makes the code much more digestible, manageable, and maintainable. So let's go ahead and start by creating those services. First service here is the let's see, this will be the what was this called? View cards, designated parking, pickup service. So this is the pickup service, right? API actually will now contact pickup service. And then we do have another service here. I'm debating. This is a cart service, honestly. This is just what it is. This is cart service. Simply put, they just want to see what's in their cart. Pickup service, right? API. This is, they submitted their order, right? And we're handling orders outside of this because it's bonus. So this is pickup service, cart service. Okay, I kind of want to redo this a little bit because I feel like I'm mixing too many components together. If it's a curbside pickup and they want you to do curbside pickup, we can assume that the user has already submitted the order and that this service, so this system we're building is actually just to handle notifying the employee. What if an employee cancels? Where's the designated parking? And handling like updating parking locations, because potentially, like, let's say Oh, and also handling like while the order is being processed, the user has the opportunity to cancel the order. Fuck, dude, I kind of want to start over because I feel like this is a little bit too ingrained, a little bit too broad, and not specific enough. So they'll be more specific in system design. Obviously, in certain cases, or a good example of this, right, is like they'll ask you to design a system. For example, like Facebook. There's a lot of things that go into Facebook, but they won't ask you to design all of Facebook. If they ask you to design a timeline for Facebook, it's literally just when you land on the homepage and users already logged in, right? So you don't need to handle authentication. You don't need to handle like the user chooses to follow someone else, right? Like all of those, I guess like meta details or like details are just kind of not within scope. And this is a little bit too broad. So yeah, it's a little crazy. If I were to redo this, let's just say that the whole point of this is actually to um, the order has been sent, and now we're designing the system to handle specifically notifying the user or notifying customer, notifying employee, and handling parking. So in that case, user submits the order already. Our web server gets it. Of course, they can always view the pickup information, and they can choose to cancel the order if and only if the order has not been fulfilled already. So if that's the case, we do have a parking uh, updates service, which includes more details, but we'll handle that later. So let's do that. This is the parking updates. When they submit that, this is actually going to be employee. Hold on, notification service. Okay, so this is we have our two services here. Let me just fucking OCD low key. Okay. So here are two services. Both of them will obviously just connect straight to our database, like so. And we are golden. So this is the high-level overview design of what a curbside pickup post or post order has been confirmed basically. If we were to redesign this and scale it, we do want to now move into the region of where is this? I'll move it down here actually. So if we're gonna scale this, we do want to keep in mind that let's say we have multiple stores. Someone called you eater. Holy fuck. Okay, so let's say so this is obviously a good system and it works for like one store. But if we have like millions or not millions, but we have hundreds of thousands of customers across the nation, and we have thousands of stores across the nation, right? This won't scale. This won't work at all. We do need to start incorporating other things, so we can start to specify things like, hey, depending on user location, they need to figure out kind of where our web servers live, to get the general location of where they're at, and the CDN will then process them accordingly. So based off that, we can then say, hey, our CDN is going to direct them to a local server that houses the location of where their order is being processed and where that whole um, process begins. Goddamn. Okay, so obviously we at this point each store. Let's say we have a server that sits in, or we have multiple servers sitting in like the West Coast, right? Does that make the most sense? we obviously don't want one web server, so it would make the most sense actually to create multiple web servers in this instance. In most cases anyway, you would have multiple web servers. We do need to think about things like load balancing, but I'll get back to that in a minute. Our API gateway here seems fine as is, but we do need to start thinking about things like our services on the back end. If this is a single point of failure here, if one of our services go down, either the user won't know where to park, which the fallback would be we need to get their license plate number anyway, or the vehicle type or whatever, but it's also inconvenience for the customer if they have to enter in that information. Probably not a good idea. So the service needs to always be up to date. Actually, fallback is a good idea because here's the thing. If the, let's say for example, someone parks in the wrong location, because that can happen. If someone parks in the wrong location, we have multiple customers, then we do need their vehicle color, or at least what type of vehicle they drive. The instances of two vehicles being exactly the same, probably not super common unless they all drive Teslas, then that would be an issue. But yeah, so our parking service updates will have two things going on here, and we'll need multiple of them, so we'll have to double up and stack up on our parking services. Likewise with our employee notification service here. Whoops. My bads. So as I said here, we're gonna double up on our services. However, for the parking update service, the employee will be able to read the orders, right? Parking update service. Should we call it parking update service? That's too broad, right? Order update service. And then this will be the employee order fulfillment service. We might have another service. We can call that the order timeline, or this will be parking location timeline service. Okay. So our order update service, as well as this employee fulfillment service, I think these are generally not going to be nearly as heavy, or I mean, we can probably just say that, hey, we're gonna have a bunch of these anyway. Damn, I'm totally gonna not pass the interview if I say, hey, fuck it, we're gonna have a bunch of these anyway. Should probably not say that. Okay. So the order update service actually instead will move to here. Move that over to the side a bit. Okay. So this is a direct connection from here to here. And so we're assuming here the employee also wants to read it. So it's a read update, order update service. It will send it over to the employee fulfillment service, based on feature flag, obviously. But if they're an employee, they log in as an employee anyway. They can also send them over to the parking location timeline service, which tells them about how much time they have left, at least for the customer, before the order is ready for pickup. I think this is good. Can I make it look slightly prettier? Maybe like that. Like that. Okay. So for this one, for the employee notification service, when the order has been placed, we do need to page them on a device of some kind. We can assume maybe they have tablets, mobile phone, whatever the case is. So we can say that this service is pulling data from the user. Do we need multiple databases here? Kind of want to say in this case, this is okay, so I kind of need to specify what databases we're looking at here. because I didn't specify it here. So I do need to go backtrack a bit and specify, well, this database itself, is it going to be using a relational database, non-relational database? What is the reason? For orders, I think a relational database is fine. I don't think the structure of the table is going to be too complex. So I would say no SQL database. Is this what they expect from front end system design? Nah, I don't think so. I think I would say front end system design is more like this. You would display like the components. You'll dive into kind of like how the API works, when you're going to be making API calls based on the functions. Kind of, I think one of my coworkers did a front end system design interview more recently. Let me see if I can pull up Excalidraw again. This is more in line with what we did before. Okay, so as far as, yeah, see how like for the front end interview system design, you're literally just talking about like your components, kind of what it does. You go through the API. You'll maybe talk about like when you want to call the API, right? In this specific example, we're dealing with, let's say you're building like a global office, right? So you have multiple offices all over the world, and the companies are they have employees in these companies, and basically you want employees and managers or anyone really in the company to be easily search for office locations from all over the world. Okay. So specifically in the front end, our steps will be here to the user will type country. Oh, and then they'll specify more in like more detailed components like, hey, this isn't just an input field. Like this is gonna be an autocomplete, right? So you need to factor in like, well, in total there's 196 countries in the entire world, right? Will the autocomplete take some time to render, or are we going to talk about like how are we going to make it so that the user experience is flawless, right? So you obviously through the autocomplete, they'll pick a country, the user will type a city, and then there's going to be a drop down, obviously, right? They won't specify drop down, but they'll tell you user type a city autocomplete, and then they pick a city. UI shows offices, and then you'll store the result here in this offices. So maybe like this will be office office list. Okay. So they'll tell you this, and then you need to go and do everything else, right? You can ask them like, hey, like what's the sample data I would be looking for? They'll give you the sample data, something like this. Like, hey, this is one example of potentially what it would look like. And so when you go through and explain like, hey, so for this autocomplete feature, obviously we want to have the user be able to type, and the autocomplete should be able to, one, filter out any options that do not match their input. Two, we're looking at displaying a visual feedback so the user knows what they're doing rather than just like randomly keying things in. So we need a dropdown, right? And we're actually going to duplicate this across the country and the city as well. When you go and build a button, you need to be more specific. Obviously, instead of a next button, this will probably be like a search button, right? If, for example, the user has not inputted anything in country, this might actually be disabled. And in fact, maybe we want to completely include the fact that um, this also has an enabled slash disabled state. And the reason I'm saying that is because like maybe it's in our best interest to prevent the user from actually typing in city before the country is selected for performance reasons, right? If we have 196 countries, the total amount of cities, I believe, is, I don't even know, man. How many cities around the world? Okay, there's 10,000 cities around the world, right? And if this data is being stored somewhere in a database, we need to make sure that the user experience is smooth. If we force them to go through country first before filtering in all the cities, this narrows down our search and actually makes our entire application way more performant. I would argue this case is going to be way better for the user experience and way more ideal in like 99% of cases than allowing them to type city or country and then search. Because going backwards like this is going to cause problems. So step one, country. Step two, enable, disabled. And then of course, when both fields are available, we're going to enable the button, right? Once they hit search, we're going to query our API and then we're going to display the office list. So here's where I kind of had a slight disagreement with how we should do it with my friend who did the mock API with me. So my no I actually I agreed with her later. I agreed with her later. My idea was we're gonna fetch countries first. So we're gonna fetch all the countries, right? And there's only 196 countries, so the data set's not huge. What we can do is before the page loads, we can prefetch, right? So we can do like so like in here, for example, we can do hello. We can do prefetch countries, right? So before the page even loads, we'll prefetch the countries first, and then when they go through and they autocomplete their input, there's gonna be a zero lag. The only issue now comes is what if our data set is listed like this, right? Our countries is basically in JSON format, and we have United States, India, Germany, so on and so forth. This can go on forever. And the problem is now we have to consider that our data set includes the cities already. So if we go in and query fetch countries, and let's say we have to go through all 196 countries, and even though we don't hit these data points, it can still be extremely performant heavy. So maybe prefetching the countries is not a good idea, right? So what we want to do actually, again, autocomplete is the same. We're not going to prefetch countries anymore. We're gonna fetch the API um, through this, and then we might want to include maybe some like caching, right? Um, whoa, okay. And of course, you can implement caching in a couple different ways. You might want to talk about how you would do caching on the front end side of things, but because when you fetch for the countries and it starts to filter them out slowly, how else could you do this? I'm trying to think. You have an API that only fetches countries, right? So your API specifically will actually only, even though your data set is everything here, because we're assuming, uh, we're assuming this is if it's being returned JSON, maybe the fetch API will go through and just select this first, this first, this first, this first. It will ignore everything else and then return countries. Great. So we'll do that, and then we'll probably handle the logic for this in some other portion, I would say. Yeah. I mean, so that's pretty much what I was thinking. You would fetch countries, right? So your API here is dedicated to only getting the countries. And then from there, once you have the countries set, right, and maybe some like Redux state. So maybe you have like, I don't know, like a Redux state, and then you have like country, like selected country like this, right? And once that country is filled, then it narrows down the search quite a bit, because now what you can do is you can fetch cities, right? And in here you would have selected city. Yeah, it's probably how I would do it, but then now you need to consider a couple things, right? So we have a fetch countries and a fetch cities. If you're going to use that as the key, that's fine as well, but then we need to consider performance issues. If there's going to be any issues with performance, how are you going to render the dropdown? Because you don't want to render the dropdown right away. If the API is still loading, you need a loader state, right? So maybe if it's still loading instead of using maybe a use to bounce, you would have in your fetch here 3 states, right? So in here you have 3 states. You have error, the actual data being loaded, and then you have loading. And so this would apply to both. And essentially, if there's an error, we show a error state. Likewise, if loading, we show loading. And then, otherwise we just return the data. So what I'm thinking here is actually your Redux state if you are going to be using Redux, but it's probably not needed. I would even argue this is overkill, right? We're just gonna call this like states. So generally speaking, Redux is overkill. The cost of using Redux here than just a local state variable is not needed. So we can actually have a country state here, which is an array of countries. So when you fetch countries, you place your countries into this array. The reason I say that is because now you have something to compare against, and you can actually reset all the countries if they decide to change their selected country. I would say the same thing here is the same with cities, right? So your cities is also going to be a collection of arrays, and maybe even actually include a state for offices. Although, do we really need that? Probably. Okay. All right. So we've gone through the states. This is basically how our API goes. We're gonna have the same thing here with, it's basically gonna be the same thing here for fetch offices like that. And we're gonna mimic essentially the same thing here, except the difference is this office list is not a drop down. So like maybe if you were to be a little bit more specific, you could say like, hey, this loading state, it's a spinner, right? This error state, instead of displaying the error state in the loader, do you want to display the error state as the input box itself? I don't know, up to you. You can just say it maybe like error, like page, something like that. And then for this one, obviously, loading is still a spinner, but if there's an error, you would display just like error text. Actually, yeah, that's better, just like error text. This is error text, and then loading, when you're fetching offices, also just like a spinner. I think that's about it as far as the API is concerned. Yeah. Okay, cool. I was writing notes that didn't mean anything to me, I guess. These are different states we're dealing with, so this is important to mention. I would definitely mention states. I would mention what type of state management system you're going with, whether it's inbuilt hooks with React or like Redux or like what was the other one called? Relay, and there's specific use cases for everything, right? Um, yeah, I think that's about it. I did mention requests, and then I went into like architecture design here. So I think if it was like a 1 hour system design interview, they would probably make you go through all this, maybe. But this is pretty much all that I think that they would focus on for front end. Pretty straightforward. Um, they might even ask you like maybe in detail, hey, so like for this autocomplete, how would you filter out the list of countries you have stored in your local state? You could probably say, well, yeah, you can use like, dot filter, or sorry, you can use something as simple as like a dot map function. Wow. A dot map function that, that basically does a callback to return an array. And then based off each country, you would dot, let me see. This is a callback function, so let's just say countries dot map each country, and in here you can do country dot, oh, you need to track their inputs. Wow, dude. So here's a good point where you can start saying, hey, like, am I going to use Zod to track inputs, or I'm going to use a standard state? Because now we have like so many states here and it kind of looks messy. You can make your case. But basically, country, oh no, this is countries dot filter each country dot or country includes the like input, right? Something like that. And then you would, obviously set state, set. Oh, I'm trying to think. This gets a little bit more complicated because you need to. Okay, so let me explain my thought process here. When you set countries to a filtered list, when you set countries to a filtered list, you're going to lose the original copy. So your best case scenario here, which is what I did in my previous project, is actually to have like original countries list to reference. And this is assuming we're not using a complicated state management. It's going to look super ugly in the front end. But if you're not using any of these inputs anywhere else in your, overall application, it doesn't make sense to use Redux anyway. The same thing here actually applies for original cities, right? Because the moment you filter it out and you replace it, it's gone forever. And you really don't want to have to call fetch cities or fetch countries again. Um, and that would just slow down your application way too much. So this is basically my final design of like how I would do the front end. Yeah. Yeah, this is it. I don't think they will ask you anything more than that. Yeah. I think that's it. Sorry, did I lose any of you? All right, well, it's holy shit, it's 9 o'clock already. I think I'm gonna actually just end it here. Hopefully that helped. This is way more accurate as far as what they'll do in front end design. They will make you map out the component for sure. So component API, you probably don't need to go as in depth as I did in the previous example, which is this one. This is too crazy. I think this is more of a full stack backend type API. You'll probably just do something like this. But yeah. And you do need to mention your states. Yeah, man. Hopefully it helps. Yeah, this is the system design my friend was forced to take. So, take that with a grain of salt. Usually though, yeah, for a front end role, that's what they do. If it's full stack, be prepared to do this. Definitely gonna happen. And yeah. I'm gonna sign off though, bros. I'm fucking hungry. So thank you all for hanging out, man. It was cool. We only had a minor disruption at the start of the stream, which is fantastic. Um, I think, yep. So I'll see you guys. I have a small interview